Nidhi, did you get the 2.7 runs any chance? Python 2.7? Yeah, Vivek, we'll look into your problem. I'll look into it soon, okay? Okay, let's start it. You got a cheat sheet? Okay. Yeah, I forgot to upload the steps to Schoology. I'm sorry. It's quite busy. I must have received a lot of mails since morning. One second. It's gonna take me a moment. Pratish, have we submitted the DPP? It doesn't come through. Okay, cool. Okay, we'll get started. Can you guys turn on your webcams, everyone? Pratish, the link has been sent to you again twice. You'll have to submit it now. Okay. But there's no executable for 3.7. There is a file beyond 2.7. I think you might find 2.7 somewhere. I'll send you the link. I'll send you 2.7. Okay. No, I have it. I have it with me. I have the file. I was using 2.7 long back. That's it. So for solving problem with standard formula, should we use SI unit? Yeah, please use the SI system always. Okay, for solving any problem. Yeah, you can install anything you want, Mithil. You can design games if you want. Pygame is there. There are many other things. Okay. Nidhi, you can wait, but you could get started also. That's fine. Either way, it's same thing. Okay, it's not going to be a problem. You can uninstall later and uninstall, and when you install the new Windows 10, you can probably restart from the beginning. Okay. Yeah, we'll get started and get marks for some answers. Review. Yeah, I know. I'll be doing a DPP review. So far yesterday, I believe most of you got your mails regarding whatever you submitted. Your DP scores you have received. Some of you submitted late. I could not help you guys correct them again. But for now, I think for most of you who did a lot of major mistakes, I've told you where to fix them and improve the score. But I could not help the ones who sent it recently. Okay, that was really problematic for me. Okay, we'll get started. Give me a moment when I start sharing this thing. I'll come to that. Okay, sure, Varun. Sure. I'll let you know. I'll let you guys know. Okay. I'll get started now for magnetism, and then we'll discuss that. We'll discuss that once we are started with this. Okay. Okay. Going ahead, we were talking about magnetic materials and all this stuff, and I just need to tell you some things. So, will we get use CGS system? It'll be easier. Certain decision you have to avoid decimal. Nah, I don't want. CGS is horrible. CGS is horrible system. Okay, it's a horrible system. Please don't use that. Don't be a chemist. Don't be a chemistry person, please. Okay, please don't do that. Yeah, please don't be stupid. That's what I meant. Okay. Now, anyways, going ahead, the Python set of fail after 4 tries. Okay, I'm sorry. We'll try some other time. Okay, yeah. Now, we discussed all this, and I told you about this, but I might have skipped this bit, which I added recently, so I just wanted to show you guys. This is about magnetic cards. Done. I didn't say chemistry people are stupid. I just told you physicists love making fun of chemistry people. That's all. Nothing. Go ahead. Yeah, going ahead. Yeah, going ahead. This is done. Done. Yeah. So I just needed to add something. There was this visualization by this one. What is that? Anika, you're supposed to send. Anika, you don't have to send your DPP again, but just correct the answers there. Okay. Yeah. Now here's the thing. This is not a FET simulation. This is a simulation by a rip-off of FET, a better rip-off actually, by somebody by the name OpenStax. Okay, OpenStax is something like um, you have this situation where you have the problem with FET is FET doesn't work really well. FET doesn't work really well. FET has some serious issues. Okay, it doesn't work on all browsers. So somebody came up with HTML5 simulations of it, and they are available on something called OpenStax. OpenStax. Okay, these are hidden from the world for some reason. They're available in the corner of the internet somewhere, and I happen to have found them. Okay, so turns out in this visualization, the beautiful part is they show the magnetic field inside what is. I told you, right? It forms a loop. I think you can see the loop here clearly. Okay, yeah. Okay, yeah. Anish, I'm not doing any coding classes. Okay, uh, not doing that. Yeah. So with that being said, so you form these loops. Okay, you end up seeing these loops clearly here. That magnetic fields always form loops. Okay. Next bit, I just need to add. Remember this part I told you. If you draw magnetic field lines inside it, we should it should tell us how many what do you say, how many field lines, how many charges should be inside. The surface told us how many charges should be inside based on the field lines outside. Remember this? Remember this bit? Yes, hopefully you guys remember that. Now, what about this case? What about magnetic field case? Yeah, that doesn't seem to hold, but the idea is very simple. If you were to take any surface around a magnet, the number of field lines leaving it will be equal to the number of field lines coming into it. Okay, always. So effectively, we call it with a more fancy term, del dot B is equal to 0. It's a very famous line. It's called second law of Gauss, which is like the fundamental Maxwell's equations. Okay, Kamit, cool. Yeah. So even if there are two magnets, inside, it just, the surface always makes sure that it works out very well. Okay, magnetic field lines always, if there's a north and a south end, then when you hold a magnet inside it, a single magnet inside or two magnets, will make sure the field lines cancel out. Okay. Now, with that being said, we were done with this. This was done. Yes, yes. We spoke about the frog doing meditation. We're done with this. I think we're done with. By the way, Ashi, I have not received your DPP. That includes even others, a bunch of. I think Medansh also, who just joined. I've not seen gotten the DPP. You have to submit your DPP, okay? On the forms, Google Forms. Yeah. Now, with that being said, I just need to tell you certain things. One, your hard drives. Your hard drives basically work on magnetic fields. Will the magnetic field lines cross if there are two magnetic fields just like magnets set like to unlike? No. Magnetic field lines can never cross each other, no matter what. That won't happen. There's no Maxwell's fundamental law. There are 4 equations of Maxwell. There are 4 fundamental equations basically of electromagnetism. Yeah, this is an HHD. This is an SSD, not SSD. I know, but the idea is that, yeah, Anvita, you saw the okay, fine, IG this thing. So the idea is that you have these magnetic this thing. So the way these things read and write stuff is Anaga here. I just want to make sure he's joining in now. One second, I just need to figure out something. Yeah, that's another. Okay. Med and Shiu, actually, I think that was accidental, I guess. I don't know. I don't know why you were out. Even Anaka was out just now. Okay. Anyways, going ahead. So you know that magnetic fields are the ones that govern what should be written on a drive or not, right? You guys know about this, right? This is something you know about. That at the end of the day, there's a spinning, what you say, a lead which keeps spinning. You might have heard some spinning motion inside your hard drives. I don't know. You must have seen it. Yeah. 1 second, Amit, you're sending too much. I will skip reading your messages completely. Okay. Anika, so why DP form was sent to me again? Should I? Yeah. In case if there's an error, Anika, just, I don't think the form was sent again. I think there was some error, so it was sent to you. I'll clarify that soon. 1 second. I opened the hard drive. Okay, cool. Yeah, there's a disk sending inside. But other than that, one more application of the magnetic fields is the microwaves. You guys know this, right? Yeah. So the magnetic fields, this is an MRI. It's called magnetic resonance imaging. So what they do is they apply a strong magnetic field, and the hydrogen atoms in the brain get excited, and they start emitting radio frequencies, and you start detecting them. So that's how it works, basically. Okay. So the child seems very happy. But anyways, other than that, one more observation you must know about is that I think I must have. No, I know where it is. Okay, fine. So, did you know this? I think you must have watched it in Interstellar. MRIs wouldn't have been possible if not for NASA. You must have known that at some point. Yeah, magnetic fields can penetrate through the body. Yeah, I think I've said it to you guys. Yeah. Anyways, so that's one thing. Second thing, your Earth generates a strong magnetic field, which helps us from this. Occasionally, this thing keeps happening. Okay, it's called a solar flare. It happens once in 10 years, they say. And the danger is if you have any satellite which is in the path of the flare, it will destroy it. Okay, so the thing is, magnetic field of the earth is produced because of the motion of the iron, the molten iron. Okay, it's generally said to be that, at least. So it is not a completely solved mystery of what produces the magnetism. It's still in the works. We don't understand it really well, the earth's magnetic field. We don't even understand the magnetic field of Jupiter. Jupiter has a magnetic field. That thing is a gas. Jupiter is a gas at the end of the day. There's no iron core there. Okay, and still it produces its magnetic field. It has a magnetic field. Saturn has a magnetic field, even though it's a gas thing, gassy object. So we still don't understand exactly what's the mechanism in those cases, but we have a theory. We have theories, but we don't know which one is right, which one is the cause for it. That's all. Yeah, now the thing is, there are too many questions. We have to not have any metal near. Yeah, they don't allow any metals near MRI because of that, because high strong magnetic field. Is the SpaceX launch? Yes, SpaceX launch is on Saturday. Done. Next, do asteroids, meteoroids, etc. in space stop this? No, they don't. Sir, can iron in the body be under magnetic? Yeah, the magnetic field required to move your iron in your blood is too weak. And second, one more detail: the iron in your blood isn't magnetic. Fun fact: it's not magnetic because of its state in which it is. It is, I think, I don't know what it's called. I've forgotten. But the state in which the iron is present in your blood, it's not magnetic at all. Okay, so that scene where you saw X-Men in X-Men where Magneto pulls up what is iron from somebody's blood, that's stupid. Okay, just saying. Going ahead. Yeah, SR, when is the launch? Yeah, it is delayed to this thing. What is that? Delayed to 052. Yeah, 12 o'clock in the morning, Sunday morning. That is. Okay. Does sun have a magnetic field? Yes, sun produces it. Sun seems to have some sort of magnetic field around it. Now, I think so. It has. Yeah, it has. Sunspots are reason for that. Sunspots. What you see as sunspots are because of that. Yep. Okay. Ferromagnetism, plasma. Yes. 1 second. A lot of messages. Are all planets magnetic? I don't know. At least most of them I know are. I don't know about distant planets. Strong. Wait. Okay. So here's the thing. A few things I need to discuss. One is, have you heard of auroras? Yeah. Now auroras are a combination of this and this. Okay. I'll come to what is that in some time when we're going to discuss a few other things. But to be honest, if our magnetic field wasn't there, we all would be dead by now. Okay. The one that actually helps us stay out there and what do you say, be alive is this Earth's magnetic field. Otherwise, you would end up all having all the solar radiation entering the Earth's atmosphere and killing us. Okay. Can organisms generate magnetic fields? Yes, they do. Some of them do. Okay. Okay, Ashay, 1 second. Yeah, you're talking about the aurora. Yeah. Why does the color of the aurora change? Yeah, I'll come to that. Remember the time? Okay, no. That is for later. Auroras are for later. Okay. I won't discuss that. I can't give away good stuff right away like that. Okay. Anyways, we'll discuss certain things and we'll come to that. Is the Earth's and Sun's magnetic field repelling? I do not know. I don't know whether it's strong enough that it can have distance at influences at such distances. Okay. Earth and the Sun's this thing. I know gravitational force is long range, but magnetic field, I don't think it's strong enough to what is it? Yeah. Yeah, I know. Okay, Amit, it does. Yes, it does. What you're talking about. And by the way, there are many creatures out there which use magnetic field for navigation. In fact, it has been said that even we have a magnetic sense. There is a small molecule in the eye which can detect magnetic fields. It's there. Okay. Yeah. Why is a magnetic field line squashed on one end? Yeah, this has something to do with the solar wind. Actually, this is not the magnetic field. What you're seeing here is not the magnetic field. That's something I want to highlight. Okay, then you'll understand it later when I speak about it. I'll come to auroras later. By the way, even bacteria have some act like tiny compasses and stuff like that. Yeah, I know. Veritas has done a video on. I think I've not seen it, but that it can produce this thing. Third thing, have you heard of ferrofluids? Now, this is something really famous and popular that's going on right now. That ferrofluids ever introduced, kind of, whatever. I think I told you, right? Pellicula has it. Okay, Pellicula has it. Okay, fine. This is physical, I know. Now, physical has one video on it, but the good stuff about it is that it is currently used. It can be controlled externally by some sort of, what you say, magnetic field. You can control this fluid by an external magnetic field. The advantages are many, actually. Is Shushruth here, guys? We have a serious issue in our hands where people end up bombing the class with your names. So I need to. Shushruth, are you joining the class from somewhere? Shushruth, are you here? Shushruth? Okay, 1 second. There's an issue. Give me a moment. This will take a moment. Where is Shushruth? Okay, I'm admitting him. So there was an issue. Okay. So what happened is that, yeah, I'll tell that later for you guys. It's fine.
Ferrofluid, this stuff. It's a liquid that reacts to magnets. A liquid that reacts to magnets. And then back to being a liquid, and then back to those crazy alien spikes. Now, these spikes are pretty unbelievable on their own, but what happens when we mix ferrofluid with this stuff? Come with me to the garage and we'll find out. And don't try this at home.
Yeah, check that, but it's easy to prepare. It's not really hard to prepare magnetic fluids. I'll optimize later. One more thing. Before that, somebody was saying something. Can magnetism be intrinsic properties of large objects? No, it's an intrinsic property of small objects only. So why Jupiter is magnetic is very strange. I don't know if it's solved or not, but I'll just Google. I don't know. Magnetic field. Magnetic field. Okay, fine. Magnetic field. Here we go. It's been said that, I don't know, magnetic field of Jupiter is, I don't know whether it's understood or not, but current theories are that it's formed thanks to, yeah, Jupiter is strong magnetic order, while its magnetic moment is roughly, yeah. It's wider and flatter than Earth's magnetosphere comparatively, but then you get auroras on Jupiter also. Can you see the auroras in the visualization? I hope you can see the auroras. They form. By the way, even Saturn has auroras in the poles. Okay. I can't find any. Okay, dynamics. There have been many theories proposed on how this works. One is some rotational currents and many other things. I don't know. There are theories, but you don't understand it completely, though. Okay, the cause for it. I'll come to auroras sometime. 1 second. Now, this ferrofluid is currently used for other applications. You know that to deliver drugs to a very specific site in the body, you need some form of agent, right? So you know those capsules which are given to you, there's always an attached molecule which carries the thing. It's called a vehicle. It carries something to the site. Its purpose is that. Okay. So Pratyush, are you here? Are you joining from another side? Are you trying to join? No, right? Okay, fine. Yeah. So the thing is, 1 second. I have an issue at my hand. Give me a moment. This will take a moment. Yeah, thank you. With that being said, Anish, are you here? Is Anish here? Guys, this is taking some time. I'm sorry. There's been issue. Technical issues. Is Anish here? Okay, I'm adding Anish. Done. Next. So the next part is, one more thing what has happened in the recent years is they're using this fluid to deliver things in the blood. Like, for example, if you want to take something inside the bloodstream, so you want to move something in a bloodstream, it's not so simple, right? You can't do that. So they're coming up with strategies where they figure out how to move something slowly, like from an external field. Rahul, that's going to take some time. Okay, that's going to still take some time. You have to wait till at least this Sunday for that. I'll get time only on Sunday, this Sunday. Can I drink ferrofluid? Don't do that. You're welcome to do it. I won't advise it though. It'll be fun for us to watch. You'll die though. Okay, you'll die. Don't drink ferrofluid. Okay, ferrofluid is it's poisonous, to be honest. Yeah. Second thing, we know that though, that we can safely have these ferrofluid-like substances which can, what do you say, uh, can be used to transfer certain things in the blood. Why ferrofluid of all things to deliver them? Because you can control them from external magnetic fields. I'm not talking about drug delivery. I'm talking about specific controlling certain. Let's say you want to deliver some very specific drug to a very specific point in the body. It's not easy, which is, let's say, which is not easy. And if you want to do that, we can the ferrofluid can be controlled from external, right? We can control using magnetic fields, where it goes and stuff like that. So this has been this has been recent development. One more development is they've been using it in cars. We know that it becomes a solid and a liquid depending on the magnetic field. So we can use it in braking mechanisms. So if you want to brake instantly, you can make this substance instantly solid, and then you can have gradual strengths depending on the amount required. So that's been the newer application of ferrofluids. In fact, this has been something that has been taking on a lot of traction because there's some amazing things being done. Drug smuggling will be easier. Okay, nice. Okay. By the way, guys, if you have any issues logging in to the class or you accidentally get logged out, here's a personal suggestion. Please, do the following. Please do the following. Please contact the office and they'll inform me, okay, in case there's an issue. Anish, are you there? Okay, where is Anish? Apparently, so this thing is having an issue. Like hydraulics, they used it in hydraulics too to some extent. Can you text? Where's Anish? There's a problem with Zoom. Okay, Anish is there, right? Okay, there's some technical issues. Okay, I'm sorry. Okay, next, there is one fun video by Action Lab on what happens when you put magnetic field on the brain. So what he does is he takes yesterday's magnet and puts it on his head. You can check it out. It's fun on your own. Second is that we have one more concern that's happening, that's been in the news lately. I don't know how true this is. I've not been following up really well. That the Earth's magnetic field is actually flipping. Now, this happens once in a few million years. It's very rare event. And when it happens, there are some serious problems caused, okay, if it flips. Because during the flip, there'll be destabilization of the Earth's magnetic field and sun's radiation will start seeping in. And that's that's going to be dangerous. But that process takes a lot of years that happen. But it's been said, even Einstein warned everybody about this long back. Like, this could be a serious issue. Okay, this is something we need to figure out quickly as possible. But we don't know when it's going to happen. It won't happen tomorrow or something like that. It's a gradual change. It happens slowly, very slow change. Okay. Yeah, I wouldn't be surprised if it happens in 2020. Yeah, 2020 is an awesome year where all the crazy things happen to us. Okay. Yeah, they say it might have ended the ice age. Yeah, it's a possibility that most of the creatures must have died because of that. The flipping, in the sense, it slowly starts moving for some reason. See, the thing is, that's what I'm saying. We don't completely understand the Earth's magnetic field very well. Okay, we don't understand the magnetic field that much, at least. I think there are theories. We don't know for sure though how it moves. Okay, pollution. This is not got to do with pollution. Earth's magnetic field does this every few million years. Okay, it does it. Okay, very slowly, but okay. Skipping that ahead, so I need to get into a new chapter now, where we'll discuss something much more interesting. Give me a moment. It's not a new chapter; it's the same chapter, but earlier I used to teach this separately. So I've kept it in a different PowerPoint presentation. So bear with me here. Okay, damn it. Let's go. Yeah. So there is a separate. This is a subtopic from the same chapter. So don't freak out. It's called electromagnetism. Humans have found an answer for every problem. Pollution. Yeah, good. Okay, so electromagnetism is I don't know, a topic that we discuss much more deeply, because there's a bigger, uh, this topic has many interesting ideas in it, which explain a lot what is the connection between electricity and magnetism at least. Okay, yeah. Going ahead, figure it out on your own. Okay. Have you heard of the Oersted experiment, Oersted or whatever his name is? Have you heard of that experiment by any chance? Pratish, are you here? Oh, you're here. But somebody is trying to log in. We need to figure out this issue. Yeah, Pratisha, look at this. Can you see this? Ta-da. Okay, I'll be a little bit louder. Is it fine? Can you see that? That's what I was asking you. Yeah. Yeah, I know that's not you. That's why I asked you. And that's why I told you contact the office in case you go out. Okay. Yeah. So somebody's impersonating you. Yeah. Anyways, going ahead. Earlier it was Anaga actually. Okay. Earlier it was Anaga. So I had to figure out whether Anaga is actually here. And then I realized she's here because of a video cam. Then I had to drop it off. Okay. Anyways, going ahead. Yeah. It's fine. Yeah. It's fine, French bread. Now, that's how accidentally came to know about electromagnetism. Yeah. I think I lost the reference model for that. Anyways. Okay. So this, yeah. You're talking about Oersted. Yeah. Now, the thing is, it was known that if you pass current through a wire and if you keep a magnetic compass nearby, it is seen that the compass needle actually deflects. Okay. The compass needle actually deflects. Now, the reason for this was not well understood, but everybody was like, maybe there's a magnetic field generator around the wire. And eventually, the theory panned out to be true that there's a magnetic field generator around the wire. Now, the question is, which direction is it? Okay, which direction? And we discussed it last time in that right-hand rule, right, of electroboom. Remember that? If the thumb indicates the direction of the current, if you hold the wire in the right hand, the fingers indicate the magnetic field. Remember that? Finger directions indicate the direction of the magnetic field. Remember? Yeah. So in this case, when you close the switch, the current will be flowing like this. Hope you agree with that. Does everybody agree with this? Okay, now I have a question. When the switch is turned on, which direction does compass A flip? Which direction does the compass A flip? Remember, it aligns with the magnetic field, the compass arrow. Either east or west. East or west. Okay, understand this. Which direction will be the magnetic field? You hold the wire, try holding that wire and see where your fingers go. So if you look at it, I don't know whether you can see this, but magnetic field lines are going above the wire like this, but below the wire, they're going underneath like this, in that direction. Can you guys see that? Yeah, it's going to be east. You guys are right. So it's going to be east. Is that fine? Above the wire, the field is in this direction. Below the wire, it's in this direction. Can you guys see that? You'll have to hold the wire. You have to hold the wire and visualize this. You have to hold the wire and visualize this. And then see the fingers. Okay? Is that fine? This is just the beginning of the Bharatanatyam, guys, where you hold the wire in the exam hall and do some Bharatanatyam. It's just the beginning. You'll see now. There are more things coming up. Should I repeat? All I'm saying is, if this is the thumb direction, hold the wire like that. Make sure the thumb indicates, your thumb is pointing like this upward. This is your thumb. Okay? Then your fingers will be curling the wire like this. If you hold it with the right hand, it'll be like this, in this direction. Above the wire, it's going to be going like this. You have to visualize this in 3 dimensions. Right thumb, sorry, right hand. You have to use the right hand. Okay, please use the right hand. Yeah, so you'll see above this thing. Yeah, so now there's going to be a lot of Bharatanatyam in this one. You'll see that. So here on the top, the magnetic field is going to be pointing this way, in this direction. On the other side, it's going to be pointing underneath in the other direction, that is the west direction. So is this fine? When the switch is closed, compass A will point in this direction. Compass B is going to point in the other direction. Is that fine? Okay, fine, Murali. Yeah, fine with that. So these are the directions, and the reason is, yeah. Is that fine? Yeah. Okay. So yeah, is this fine? So magnetic field is around it. There's a magnetic field around the wire. Hope you're fine with this. Yeah. Now, how to visualize the pattern? The way you suggest is, you have this current which is flowing upward like this. All you got to do is, why is it opposing for B? Wait, why is it opposing? Okay, the thing is, it's underneath. This part is underneath. Compass B is underneath. That's why. See, the idea is, if the thumb is like this in this direction, the fingers will be coiling like this. Agree with that? If you hold it with the right hand, if I'm not wrong, your fingers are going to go around that way. Yeah. So on the top, the field is like this, but underneath, it's in the opposite direction, this way. Magnetic field is like that. You have to visualize this in 3 dimensions. Okay. Yeah. Now, next part, this is what it looks like. So the magnetic field looks like this. If you hold with your thumb, if you hold it with your right hand, the wire, If this is your thumb, current direction indicates the thumb, the fingers will be indicating the direction of the magnetic field around it. Is this fine? And they form concentric circles, perfect concentric circles. Hope you're fine with this? Yeah, fine. Next part. Nah, Murari, not happening. Okay, next part. So magnetic field is stronger at the center compared to, so the number of field lines, the circles become wider and wider as you go further and further away. Is that fine? Closer, there are more field lines as you go closer and closer. Yeah. So yeah, this is the right hand rule. Please, whoever did not get it so far, hold the wire like this. Okay, hold the wire like this. The thumb indicates the direction of the current. The fingers indicate the direction of the field around. Okay, so right hand, right hand, right hand. This is R, right hand. Hope that's fine. Yeah. Is everyone clear with this? Can I get a yes or no? Just need to proceed here based on this information because it's AC current. It's DC current. Sorry, DC, regular current, normal current. Don't get AC unless asked for. Yeah. Hopefully everybody's fine. Yeah. Okay. I want to show this video, but not now. We will take some time. It might get okay. Yeah, it's doable. We can show this. So this is an explanation for why this happens. Why is there a magnetic field around? Okay. But I think I'll go to the end of the chapter and somebody should remind me to show this video. Is this fine? How special relativity makes magnets happen. Why does it happen? Okay. I need to explain you some detail because I did this first in the other batch, and that I don't think they got every aspect of it really well. So if I need to explain towards the end, I think things will be clear. AC is not strange. I'm sorry. I've shown it last year, Murali. Okay, nice. Okay, why would I show that? What is a chapter and what is the reason? I don't know. Yeah, this is a compared smallest chapter. Okay, listen to this. There are some representations. So listen to the representation. This is important. So some representations are, first one is that the magnetic field, if you write it this way, it means the current is coming, this represents that the current is coming out of the paper. Is it fine? Towards you. Wire is coming towards you. And the field lines are going to be around that. Is it fine? Is this fine, guys? Does it make sense? Pratisha, that frame won't fall. Okay. Anyways, is that fine, guys? Yeah. So next part, if it's this represents the X cross represents that the field lines are going into it. Okay, Murali, that's fine. Okay. So this indicates that the wire is going into the paper. Now I don't know. You can do your Bharatanatyam again and point the finger out of the paper, your thumb, and you'll see the field lines. Your fingers will represent the field lines. The idea is very important. If the wire is coming out of the paper, then the field line direction is clockwise, anti-clockwise. If it's into the paper, it's clockwise. Is this fine? Can I go to the next? This is some notation, that's all. Do not forget this. Yeah. Medansha, I'm sure you got it. Shashank, I must have missed it. Shashank MN, I'm talking about you. Okay. Now here's the thing. What do you mean into the paper? That's the wire is coming to your face, let's say. Straight away from the screen, directly to your face. Like paper, the wire is coming out. And all the current is flowing towards you. Are all the field lines in the same plane? No. Each field, so the thing is the field is everywhere, even above, right? So, oh, you're saying given one field line, is it on the plane of paper? Yes, this field line is stuck to the plane of paper. This one field line. But then there are field lines at every, every cross section of the wire. There's a set of field lines. Is that fine, guys? What do you mean by into the paper? Into the paper in the sense that the wire, the current, the thing is the wire is coming out of the paper like this, outside. In this case, it's going inside. The wire is there, the current is going into that wire. That's what it means. So every loop is in the plane. No. Every loop is not in one plane. To be honest, this is what it looks like. If this is the wire, then the magnetic field will be around it at every point. Is that fine? There will be many cross sections of the wire, and what it shows is a single cross section of the magnetic field and the wires. Okay. Now field lines don't form a sphere. Shashank, I got that. Bharatanatyam. Okay. What if current flows instead from the bottom to the top? Don't worry about that. We care about only field lines going in and coming out for now. Accordingly, it will be other things will be according to that. The whole thing is three-dimensional. Yes, the whole thing is three-dimensional. If you want to see what it looks like, oh, by the way, one more thing. This is what it exactly looks like. One second. This video, this will show you properly. This is what it looks like. There'll be fields on top also, top of this also. It won't be just in that one plane. Everywhere around the wire, there'll be a magnetic field around. Is that fine? Now, does it feel 3D-ish? You don't require 3D glasses. Does it feel like 3D-ish at least? Yeah, okay. That's my point. My Picasso-like skills are finally transcending the third dimensions. Okay, nice. One more thing. What is that? Okay. Yeah. Okay. So with that being said, I need to add a few things. If the current is more, the field lines will be stronger. Is that fine? There'll be more field lines closer to the wire. Does that make sense? Okay, field lines will be lesser. Can I go ahead quickly? Yeah. Depending on the strength of the current. If the current is more, the field lines are more. Shashank, what did you not get? Previous slide. Yeah. This is not too hard. Is it done, guys? Anish, no. Oh, by the way, I'm not teaching Python to you guys. I'm just throwing some coding ideas at you guys whenever I get time. Okay, that's all I'm doing, technically. It's not exactly per se coding classes as such. Okay, it's just that somewhere or the other, I'll just throw something here and there. Oh, if the currents are higher, it says if the current is higher, if I2 is higher, okay, if it is higher, then the field lines will be stronger. That's what it means. Is this fine? Can I go ahead? Before a bunch of you take me and start punching me imaginarily for slowing down the class. Is this fine? Yeah. How do you measure the magnetic field? I'll come to that. Okay. Next part. What is I2? I2 is a higher current. That's all. Okay, done. Now imagine this. What if I took a wire and I looped it like this? What if I took a wire and looped it like this? Now, do you see something interesting? The current flows like this, comes out of the paper, comes out of the plane of paper, goes in again into it, and then comes out from the other side. So now, if you see something interestingly, here the field lines are going to be clockwise, anti-clockwise from our viewpoint. It's going to be anti-clockwise. Can you see that the current is coming out of the paper? Now, as it goes into the paper, it's going to be clockwise. But do you see in between the field lines get added up? They become stronger. Yeah, this actually happens. It's okay. Do you see the field lines get added up in the center? Because one is running clockwise, the other one is running anti-clockwise. This is anti-clockwise. This is clockwise. So, because the current is going into the paper, the current goes into the paper. The field lines are everywhere, by the way. Field lines are in everywhere around the wire. They're everywhere. But the idea is, so no. If they're in the same direction, how can they cancel out? If they're in the same direction, both of them here, they won't cancel. They get reinforced. They can become even stronger. They become stronger. Two magnetic fields can get added up if they're in the same direction. Their fields are right at the end of the day. They get stronger. Yeah, at the center, it's going to be much more straight. The field is going to be more straight at the center here in between. Do you guys get that? I don't know. If you had a loop of wire, the idea is that field will be everywhere around it fully, completely, throughout, everywhere. The idea is in between, you'll get this adding up effect where field lines get added up. No, this visualization should tell you that the field lines are going like this everywhere. Okay, the field lines are anti-clockwise here, and here they're clockwise. If you see, they're going around the paper in a clockwise direction. But in between, they get added up because the currents are flowing in the opposite directions in both the cases. Okay, I hope that's fine. Now, based on this, I just need to add a few things. See, I told you, right? In one case, the magnetic field is clockwise, in one, it's anti-clockwise. That's what's happening here. If you look at it, this exactly is this one here. It's coming out of the paper. Okay? Yeah, the right hand thumb rule is very important. Very, very important to indicate the direction. Okay, by the way, for those of you who are not getting this, hold this wire with your right hand. Come on, hold it. Imaginarily. Okay, hold it and then see where the fingers go around. Watch the fingers go around. Those are the magnetic field lines. What if both are clockwise? I'll come to that. Yeah. Can you find a manifold that resembles these curves? Seriously, use the word manifold. That's a big geometry word. Okay. Why do they get added up? Because they're fields. Fields always get added up. They follow the principle of superposition. They get added up always. Okay. They can cancel each other and add up in a given region of space. Okay. Now, with that being said, have you heard of a solenoid? wire that gets coiled like this and you pass current through it. You told me, can you find us manifold, right? Can you send that a question again? Shashank, yeah. Anish, don't do that. But they don't pass through each other coinciding. Oh, by the way, they get added up. One is above the other. The field lines are above the other. So they get reinforced. The field is there. Okay. Listen to this now. Do you see something interesting here? It's formed a loop, right? When in one direction the current is going up, in the other direction the current is coming down. So if you look at it in between, do you agree the field lines have to get added up? Do you understand that logic? Yeah, there are problems, Rahul. Yeah, this is exactly what I was talking about. Everywhere, because there are some regions where it goes up and forms those loops, the field lines get enforced between the coil, in between. For that, you need to understand the previous slide. There's only one loop. In one loop, you increase the magnetic field in the center using one loop, a single loop of wire. Okay, but now you have multiple loops here going on. One loop going like this and second one like this continuously. This ends up to continuous, reinforcement. Many, field lines getting reinforced. So this is when it gets stronger. The magnetic field gets crazy stronger in the center. Does that make sense, guys? 1 second. Is the middle one completes the loop? I didn't get that. But when one is clockwise and the other is anti, aren't they in opposite direction? How do they add up? Oh, they're not in opposite directions. If you have a magnetic field going like this, this is electric current going like this, the field lines are around it probably like this. Yeah, like this. In this direction, this way. If the wire is carrying current this way. If it's in the opposite direction like this, then the magnetic currents are going to be like this. The magnetic fields are going to be like this around. Do you see they get added up? Yeah, they get added up. They get added up. If they're in opposite direction, they get added up. No, Sumit, I'll not come to that. Not here. Yeah, it's in opposite directions. Is this fine? Okay, the idea is simple. It's based on the previous idea that if they are in opposite directions, the idea is simple. If I told you, right, this is something you must have understood already. Once you understood this, you know that if the field lines are, if the magnetic field is in anti-clockwise direction and here in the clockwise direction, in the center of this loop, the field lines get enforced. They become stronger. Okay. The same thing happens here. Here there are many loops like that. One carrying current like this, the other loop is carrying current in the other direction. Again, going up other direction. This causes a strong field in the center. That's what I'm trying to get at. Yeah, they get added up. They get added up. Are more fields in the region? What? I didn't get that. More strength? Yeah. Stronger is the field. The field is stronger in the center. The magnetic field in the middle of the solenoid completes the loop. Yeah, by the way, I told you we form loops, right? Magnetic field lines always form loops. You can see that there's a loop formed here. The magnetic field line forms a loop there. That's one of the points. Yes. Keithan, you're right. What if it's in the same direction? I'll come to that. That is later. That's for later. Okay. You can imagine what's going to happen if they're in the same direction. You can visualize that. If the currents are going in the same direction, you know what's going to happen in the center. Are clockwise field and anti-clockwise field positive and negative? No, they're not taken positive and negative. They're just there around there. One is going in the other. It's just the direction that matters. Okay, don't take signs into account for now. Yeah, in the loop, the magnetic field is the strongest in the center of the loop. Is this fine? Is this part clear so far? Can I get a yes or no? What do you mean by different direction? The current, see here, the current is going upward like this, behind the loop. In the front, this wire is taking current in the other direction, opposite. If you see, this one is taking the current up, but this part of the loop is taking current downward. So wires are in opposite direction, carrying currents. So in the center, you'll get reinforcement. Anish, skip that. Yeah. Next part, do you see this seems like a magnet? There's a north end and a south end here. There seems to be like a north end and a south end. Do you see that? This acts like some sort of magnetic field. As it acts like a bar magnet, it's a giant bar magnet. It's as if it's a giant bar magnet. There's a north end here, and then there is a south end. Yeah, the north field. No, by the way, this is accidentally written wrong. This is an error. But north end is here, south end is here. That's all. Yeah. Thing is, we can create even stronger magnets if you use more loops, more coils. More coils, we can get a stronger magnet. So I don't know whether you saw that this Veritasium video yesterday. Did you see that a coil he had? He had a coil like this, and there was a copper winding, orange color copper winding, which he lifts up with this thing, passes current through it and lifts it up. Veritasium. If you remember it, if you remember. Okay. We'll deal with that later. You might ask. That's a solenoid. Okay. So solenoid can produce strong magnetic fields. Okay, that's the point. Where the magnetic field is the strongest in the center. Now, with this logic, you can create very strong magnetic fields, like crazy strong, however field you want. But you have to pass large currents. You know, more the current, more the field, right? Agree with that? More the current, more the field. So one is more the current. So how to increase the field? You have to improve the number of amount of current. But you know, if you increase the current, the wire starts burning. So that's not good. So you can't increase it infinitely in case even if you want to. So one more method is, if you get these coils closer, do you agree there'll be a lot of currents going on very close to each other? If you have many windings, if you get the windings very close, here also, do the field lines get added up? Yes, there is field lines due to each of them which get added up. They get added up. Okay, because they get added up, it's reinforced in this direction. Okay, hope this is fine. This is nothing much here. Oh my God. Okay, so solenoid field represents that of a bar magnet. Okay, so this can be used as electromagnet. Okay, I don't know, Sumir. Yeah, this is called a solenoid. Solenoid is this one. This is called a solenoid here. It's basically a coil which produces a magnetic field. Okay, with this thing. If we go closer, won't the field be stronger? Yeah, if you go closer, just like a magnet, it's stronger. But the strongest field is inside the loop. Inside the loop, the field is crazy strong. So you can take advantage of it to do some experiments inside, where magnetic field lines are parallel and stuff like that. You can play around. Actually, I've done some experiments in my bachelor's where it involved me creating a structure like a solenoid and started playing around with the magnetic field inside. So I needed to figure out whether magnetic fields affects crystal formation. So what I did was I had to create strong magnetic fields. So I introduced the crystals inside the core of this as much as possible to improve the field. So this is one example of that. I meant a loop of each of the coil. If we get closer, yeah, if you get the loops very close, if there are many loops, let's say 100 loops per meter, let's say, the field is much stronger. Okay, if the field gets much more stronger. So the strength of the field depends on number of loops per meter. Okay, next one. I didn't get that, Vivek. Okay, fine. Next part is there's a way to figure out which is the, what if you go inside? The magnetic field is strong there. That's all. If you go inside. Now, one more detail. It's been known that if you can also use the right hand rule to figure out the direction of the magnetic field in a solenoid. The current indicates, the fingers indicate the current direction, and this thumb indicates the north pole usually. So it works. That's a faster way of looking into it. This is fine. Good for you, Shashank. Okay. Shashank Pujari, that is V. Okay. Is this fine? Are we not a diamagnet? Our bodies are diamagnetic, yes. So why? So we'll expel the magnetic field, you're saying. We would float. But the field is not strong enough inside. Okay. Next part, there are two ways to increase the field of a solenoid. The first one is increasing the current. Second one is increasing the number of turns per unit length. This matters because how many coils you have per unit length determines the strength, not the number of coils you have. If you have 1,000 coils and if they're spaced like kilometer apart, it's useless. You don't get strong fields. MRI is done in a much more complicated way. MRI is much more complicated. Is this fine, guys? Is it solenoid or whatever? Up to you, how you pronounce it. Now, is this part fine? Now, I just want to add the third point. Does anybody understand why does this work? Why is it called soft ion? That's one more additional word that's been added, soft ion. If you use a soft ion core, you can get even stronger field, it says. Why does this work? I've explained what is soft ion yesterday. Soft ion loses magnetism faster, but it gains magnetism faster also. Hope you know that. Pratisha is here. This time Pratisha is actually here. Because it's soft, aligns the fields. Yes, that's exactly right. That's right, yeah. Pratisha is here. She's not there. I think she's actually outside. Once again, Lalada. Okay. Yeah, it captures the magnetic fields. Remember this last time I told you? See, if you have an iron bar, if you have an if you have an iron bar, then if you have a magnetic field north end and the south end, I told you that the field lines prefer to go inside as much as possible, ending up polarizing this thing. It creates a much more stronger this thing. What is that? Magnetic permittivity, a medium where magnetism can flow easily. So you'll have this strong reinforcement. You'll get more magnetic field lines inside. Remember this? It's as if the iron core itself gets induced. Yeah. So this improves the magnetic field. I'll come to this why. Give me a moment. There is a video. Okay, this video will explain you properly what I was talking about from that time. So if you didn't understand anything so far, this video will summarize that for you. Okay. So this is a visual experiment, visual part of the aspect of it. Okay, this is very good. I don't know whether I've shared. So it is best if there are many coils around a soft iron pole-ish. Yeah, exactly. Nice choice of words there. Okay, fine. So yes. That intro music was too much, I know. 1 second. Don't wear headphones next time. Yeah. Can you guys see the video?
The causes of magnetism, and the in which we can see those shapes.
Yeah, you can see the
shape of field round.
Can you see the iron filings forming small circular structure there? Can you see it? Small circular structure.
A single wire and round a coil. The ways in which we can see those shapes and the explanation behind the shape. The magnetic field explanation.
Okay.
Creating the field around a permanent magnet are the moving charges of electrons within atoms within the material. Within magnetic materials, atoms exist in small groups which we call domains. However, within that magnetic material, adjoining domains are unlikely all to be aligned in the same way. In many cases, however, particularly, for example, in soft iron, those domains can be aligned by an external magnetic field. So that material in itself then becomes magnetic.
Okay.
Magnetic fields are vectors. They have size and direction. The field can be highlighted by using iron filings on a piece of paper, but remember that it is a three-dimensional field. It is not just flat. In drawing the field, we use simple black lines with arrows showing the direction.
Shashank, that's because of something called because of randomness. That's it. Okay.
The closer the lines are together, the stronger the field. In this drawing, none of the lines should cross.
Okay, this part is important.
Having said that all magnets are produced by a moving electric charge, let's look at the most simple situation. We have here a battery, a wire, and the wire passes down through a piece of card. We have a look at the magnetic field around the piece of wire. We tap the card so the identifying line and numbers on the magnetic field. Over here, we need a considerable definition.
Now do you get what I was talking about? The field line going into the paper. Hello? Are you guys there? Have I lost you? Yeah, I lost feed for some weird reason. Couldn't hear. I know. 1 second. I'm going back. Yeah. Now, do you see my answer earlier that I told you about that field lines are going to be, what do you say, going, the wire is going, current is flowing into the paper and out of the paper. Does it make sense now? That idea? Hope that makes sense. Yeah. Okay, 1 second. I'll be playing the video. There's some chat. 1 second. I'll look into the chat. Now is the voice fine, guys? Can I get a yes or no?
Yes.
Can I get a yes or no on that? Okay, what is this? This is weird.
Yes.
Yeah? Okay.
It's a circular magnetic field around the wire. The magnetic field is circular and clockwise when we look in the direction of the current is flowing. we would hope to make out the magnetic field near the wire where the field is strongest. Bunching several wires together, we expect to be able to see the magnetic field more easily, particularly close to the wires. We're doing this here using the same procedure. We can just about make out the circular pattern, but it's hardly outstandingly clear. If we put a compass near the wire and switch the current on and off, we can see the needle swing.
Volume up. Can't hear? Guys, can you hear? I'll increase the volume. Okay. I don't want to burst somebody's headphones if it is. Now?
From its north.
I can improve the frame rate. But I might lose my zoom feed. The moment I try to do that, sometimes we lose our zoom feed. Okay, so I'm just trying to manage it barely, like without. Oh yeah, now can you hear the sound?
Particularly close to the direction that the current is flowing. We would hope to make out the magnetic field near the wire where the field is strongest. Bunching several wires together, we expect to be able to see the magnetic field more easily, particularly close to the wires. We're doing this here using the same procedure. We can just about make out the circular pattern, but it's hardly outstandingly clear. If we put a compass near the wire and switch the current on and off, we can see the needle swing from its north steady position to a tangent to a circle around the wire. A lot of early work in magnetic fields was done by a man called Maxwell. He defined the direction of the magnetic field around a wire carrying a current, and it's often called Maxwell's corkscrew rule.
Keaton asked, why is there a space between two magnetic field lines? I told you, the spacing determines the strength of the field. If the field is strong, in field line representation, if the field is strong, then the lines are much closer. Okay.
If the corkscrew is screwed in a direction of the current, then the hand-looking field, as the battery here is connected, the compass moves around much more quickly and immediately than it did before. And the iron file...
Shashank, I need to add one more thing. Randomness is a very important aspect of symmetry, which leads to that. Okay, what we were talking about. Okay, just adding. Oh, can you see the filings now? Can you see the magnetic field? This is a solenoid. Can you see that? Can I get a sound on that? Yeah.
Into a very obvious pattern. We'll examine the shape of this magnetic field just a bit more carefully.
Listen to this explanation carefully. This is really good what he's going to explain. He's going to try doing this in 3 dimensions. So listen to this carefully, okay?
The coil is a small version of a simple spiral coil like this. If we picture that spiral coil and then cut it across the middle along this line.
Do you guys, will you be able to visualize that? You cut it exactly in half in center. Okay, I hope you agree that somewhere in these pieces, some places the current will be coming out of the paper, some places it's going to be going into the paper when you cut it. Okay, observe this.
We would see the ends of the coil on each side. The current would be flowing up on one side and flowing down on the other.
Does that make sense?
The crosses represent the conventional current.
The idea is, can you see my cursor? Can you see my cursor by any chance? Anish, 1 second. Yeah, so the thing is, here the field line will be going into the paper, the wire will be going into the paper, but it will be coming out of here, this point here. Again, the same wire will come, will be going into the paper here and coming out of here. So into the paper, out, in, out, that way. Is that fine? That clarifies things, right? Just some of you might struggle with that, so I just mentioned it. It's fine, it's fine, it's fine. Cursor is stationary, but you get the idea, right? But you get the idea why it is crossed and why is it some places going into the paper, out of the paper. Is that fine? Yeah, just need to add that. Shashank, if there's no gap, you would have a single wire. No gap. Yeah.
Flowing away from us, and the dots represent the current coming towards us. If we then, rather roughly, draw in the circular magnetic fields around each of the wires, these will be clockwise at the top, since the current is flowing away, and anti-clockwise at the bottom, since the current is there flowing towards us. The fields around each of the wires interferes with those next to it.
Okay.
Between the wires.
Do you agree in between here, will the currents, fields cancel off or do they add up? Tell me. In between the wires, between any two consecutive wires. Look carefully, look at the directions, and then tell me. Look at the directions in between the wires. Not in the middle, not in the middle. Adjacent wires, adjacent into the paper wires. Remember, you were asking what would happen if currents go in the same direction earlier. Can you see there are two cross wires going in next to each other? So you'll understand what's going to happen there, the fields.
The fields are in opposite directions, and so they cancel out. But above the wire and in the center of the coil, the fields reinforce one another.
They get added up.
This results in a strong magnetic field down the center of the coil and a noticeable, although weaker, magnetic field in the opposite direction around the edges of the coil. In fact, the field...
Is this fine? Did you guys get this? Because this is the one that properly explains what's happening. Here they get cancelled off. In between they get cancelled off very easily. Okay, Saujanya, thank you. Yeah. What's the doubt? Sir, Vivek, yeah, tell me. What's the doubt?
Field down the center is likely to be particularly strong, remembering that this is three-dimensional. There are parts of the coil above and below the diagram as well. We should be able to...
This will show it to you properly.
See the magnetic field more clearly with this arrangement. An open copper coil threaded onto a card, onto which we can attach...
Now, for those of you who didn't get it earlier, can you see here, wire is going into the paper and here it's coming out. In all these places, the wire is coming out. Here it's going in. Can you see that? On the top part, the wire is going in some parts, wire is coming out. So you can see the magnetic fields now. Okay. So you said it will form a wire, but wouldn't the wire be hollow? Where it will form the wire? I didn't get that part.
Battery. The 9-volt battery will drive a large current through this low-resistance copper coil. The iron filings scattered on the card highlight the magnetic field. You can see that even with these few coils, the magnetic field is...
Can you see it properly here? Can you see it actually stronger, really strong in the center? I think it's very clear here in this diagram. The solenoid, no gap. No, if you can't touch the next wire, that's why you put a coating. It can't touch. It will end up in a short circuit, as it say. Yeah. No, it's not a short circuit. There is some resistance in the other part of the circuit. Don't worry. This is just a small portion of the circuit. There's resistance somewhere else.
Strong and easily identified. Returning to the small coil, notice what happens when we put a nail...
Okay, watch this. This is a part which is very important, okay?
...near the end of the coil, and then we switch the current on. The nail is jerked into the coil. If we start again with the coil and a current flowing through, scattering iron filings around.
Can you see the field is very strong right now already? It's very strong, right, comparatively, with so many coil turns. See, the point that matters is how many turns are there per meter. That matters per distance to get a strong field. It's not just the number of turns. It's also the number of turns per this thing. Okay, next part.
But then slide the nail inside the coil.
Watch that. Look at the strength increase suddenly, like crazy strong, just because of an iron nail. Can you guys see that? Field lines, they're much stronger.
Notice how much the magnetic field is increased, not only near the ends of the nail, but around the sides of the coil as well. Redrawing the diagram similar to the one we had before, the magnetic field through the coil. If we start again with the coil and a current flowing through, scattering iron filings around, but then slide the nail inside the coil. Notice how much the magnetic field is increased, not only near the ends
Vivek, in that case you will get a stronger field, that's all.
Of the nail, but around the sides of the coil as well. Redrawing the diagram similar to the one we had before, the magnetic field through the coil is in loops, that is, down the center of the coil and then around the ends of the coil, in a complete loop.
Yeah, Keaton says, is it good to take thinner wires because you can have many number of turns? But the problem, if you use a thinner wire, you will have larger resistance. Okay, that's the challenge. Second thing, the wires cannot touch each other. You have to have good insulation coating between each wire. Third, if you have thicker wire, the advantage you can have larger currents. You can have very large currents. Like you could go up to 3 amperes roughly. I've seen 2 amperes being run and wire almost, it gets heated up, but it's not sufficient enough. It's large current. Okay.
When we introduce the nail, that magnetic field is much stronger. There are more lines and they are closer together. That is because the iron nail has much greater magnetic permeability than free space.
Yeah, now that word where he used, he said greater magnetic permeability. Yeah, that's something we kind of care about because that tells us how much does the space resist the magnetic field. Like, for example, remember that constant K in the beginning, Coulomb's law, K? Ke, yeah, that K is actually 1 by 4 pi epsilon naught, 1 by 4 pi times epsilon naught. Now, epsilon naught is a factor which determines how much, it's called the permittivity of the electric field. It's a permittivity of the electric field. It restricts how much the electric field wants to propagate through space. So both of them are responsible for the speed of light. The speed of light factor that you get, C, is related to both these constants. Okay, because these both determine, whether, what you say, how fast light will travel, because these are ones that tell you how fast the fields can change. Okay, it's this is 1 by 4 pi epsilon naught permittivity. Okay, that's not very important, so don't mind it, but it's just 1 by 4 pi epsilon naught. You can Google it and find it out later. Okay, it's not a formula as such, it's just an idea. So just Google it, permeability and permittivity.
It is much easier for the magnetic field to form in the iron, so the total field is much stronger. Although it is rather untidily and badly drawn here because I've allowed two lines to cross. That also explains why the nail was pulled into the coil. The increased permeability of the nail reduces the total energy of the magnetic field when it moves in.
Yeah, that part is slightly tricky to explain, but that is something I can explain in the last chapter, why the nail gets snapped into position. Okay.
If instead of having a straight iron core, we had one which was horseshoe shaped, then the magnetic field created by the current flowing through the coil would largely be within the iron core, and only a small amount of it would pass through the air. The magnetic field would therefore be a great deal stronger still. That's why strong permanent magnets and electromagnets are usually this shape.
Remember why we have horseshoe magnets now? This is the reason. Horseshoe magnets have the positive and negative core very close to each other. So having the positive and negative very close. Remember yesterday's video? Those magnetic north and south on the same surface? If you remember, yeah. That's what I'm talking about. It's stronger if you have that kind of arrangement. So you get stronger and stronger magnets. What if you put a magnet instead of an iron nail? That would make a difference. You have to put it in the right direction, but don't put it in the reverse direction. Put the north in the direction of the solenoid, north, then it will be fine. Put it in the reverse, then it's going to start impeding the field, cancelling out the field. So you can put a magnet instead of an iron, but as long as you're putting it in the right direction. It's basically the iron is getting turned to a magnet, that's all. Iron is getting switched on and getting turned to a magnet over there. Okay. Now, these magnets are usually shown in cartoons. Yeah. How will we freely suspend horseshoe magnets? Yeah, you can't do that. If you freely suspend a horseshoe magnet, there'll be some weird torques and rotational forces and stuff like that. That'll be weird. So, yeah. Now, through this concept of solenoid, can we make a working model of a toy, making it move through solenoid or something like that? Yeah, kinda. I'll come to it. I know what you're talking about, Anvita. I'm getting there. I'm going to discuss that in some time. Okay, that'll be much more interesting. How to make a toy out of this. You know this, which video I'm talking about. Yeah. Okay. Anyways, going ahead. One second. Next video. Next topic. Sorry, next video. Next one is also a video. Expected this. It's like Anvita predicted this is going to be the video next. This is by Physics Girl. Okay, there is an interesting toy, a fun toy that can be built out of this idea. Can you guys see the video now? It's called electromagnetic train or something like that. It's the easiest train to build. I don't know how many facing.
Welcome to my floor.
I'll try to optimize the video for sharing this thing. Let's see.
I think this is the first video I've ever filmed on the floor, but desperate physics calls for desperate measures or something. So I found this video online of the coolest little contraption. It was called World's Simplest Electric Train. I'll put the link in the description. And it was
that's not possible, sorry.
This little setup, a spring, like a coil like this, made out of copper, and then a battery with magnets attached on either end, just like this. And you stick the train in one end of the...
You can do it, but it's bending. But if you can bend it, then it's fine. If you bend it, it's fine. But it might lose its magnetism in that direction, might switch, doing some weird things. That's possible. because you know that if you get a north and a south pole very close, it will force the other to bend in some direction. So that's possible. It can be done. It can be done. I'm not denying that, but it'll be hard, very hard.
Coil, and it just shoots through, kind of like this. When I first saw this, I thought, blimey, that is so simple and so cool. I have to make it for myself, but I have to make it better, which is why I have tons of cylindrical and spherical magnets all over the place. And you'll notice how far apart all these magnets are because they're neodymium magnets, and they are so stupid strong. They will fly together and they will pinch you. Not that it's happened to me 10 times already today. It's on. Ow. Oh no. Move out. Oh no. And it's just a mess here because I wanted to make the best, most epic electric train, and I made the world's longest copper coil track. I'm all about those world records today, but they're actually not world records. We've got our track. This was 195 feet of like 20-ish gauge copper wire. And so I'm gonna hope that this is gonna go all the way around. We're gonna get a full loop. Let's see. Here we go. Woo! Yeah! Oh, it's coming around. Yes! It is going so fast. Oh, we're stuck. This is awesome. I feel like a little kid. Oh no. Disaster. So I cannot go on with life without talking about how this works. So we put magnets on either end, which should be a clue as to what's going on. One magnet goes on the positive terminal and one goes on the negative terminal. Then when you stick this magnet train into the copper coil, and ideally the magnets are going to be bigger than the battery so that the magnets are touching the wire. One of the magnets touches the coil on one side and one touches on the other side so that you get electricity, you get electrons flowing through the coil. When you run electricity through a coil, it makes a magnetic field like this. And you can tell that current is flowing because sometimes, like if you flip one of the magnets around and then try to push it through, it'll actually spark sometimes and it just vibrates, it won't go. So why do the magnets have to be in a certain orientation?
This part is very important. Listen to this. The whole reason why I got you to the video is to listen to this. This part matters a lot. Okay, it doesn't have to be copper. It doesn't have to be copper, Pratish. You can use gold. Gold is the best if you don't want copper. Okay, going ahead.
In an electric field, bear with me, in an electric field, a negative electric charge will feel force in one direction and a positive electric charge will feel a force. It'll be pushed in the opposite direction.
Is that fine? Does that make sense? Common sense, right? No, I'll come to that, Nidhi. There's a reason for that. You'll see the reason why now, okay? Is this fine, guys? A positive one will go towards the negative side. A negative side will go in the electric field. The positive charge moves in the direction of the field, moves in the direction of the electric field. Now listen to this part.
In a magnetic field, it's very similar. A north magnetic pole will be pushed in one direction in a magnetic field, and a south pole will be pushed in the other direction.
The idea is a north pole always goes in the direction of the field, just like the positive charge, and south pole goes in the opposite direction. If you have an independent north pole, is this part fine? Can I get a yes on that? Yeah. If you get that, now there is something amazing here. But do you ever find an independent north pole? Never, right? You always find a north pole beside a south pole. Yeah, so this leads to something interesting.
The problem is that you never find north and south poles without the other. So if you just put a magnet with a north and south pole in a magnetic field, it's not going to move.
Do you guys get that? There's no magnetic monopoles. There are no magnetic monopoles. Well, at least not yet discovered. Can you use battery and use it to find which of the two metals in the question you gave is a magnet? Yeah, you can use a battery and do it. Yeah, you can use a battery and do it if you have access to a battery. Yeah. Okay. Why do north and south poles of the magnet not realign themselves when you switch the direction? Yeah, when you switch the directions, what's going to happen is, observe this part here. When you have it this way, I'll come to that. First, did you guys get this part? That in this case, since you have a north and a south in the same direction on the same part of the magnet, one is going to get pulled in one direction, the other one in the other direction, opposite direction. Okay, so observe this now.
But if the magnetic field is not the same all over, the field is not going to move. But if the magnetic field is not the same all over, what you call a non-uniform magnetic field.
Okay, I have a question. Where is the magnetic field stronger? Is it to the right or the left? Left side or right hand side? Which side is the magnetic field stronger in this case? Clearly it's on the right, right? There are more field lines here. There is more spacing here. So now observe what's going to happen.
You might feel a slightly bigger push on the North Pole than on the South Pole.
And North Pole moves in the direction of the field. South Pole goes opposite to the direction of the field. Is this part fine? So if you have an ununiform magnetic field, if you create an ununiform magnetic field, the entire magnet will start moving. Magnet will experience a force. So whether the magnet experiences a force or not depends on this part, this aspect. Now, for this to work, you need to see one more detail, that the north end should be on this side in the direction of the field, and south end should be on the opposite direction. Can you see that? The south side of the magnet should be in the other direction. Is this part fine? That should help. Now I think you can understand it, Nidhi, if you understand this explanation. Once again, I'll play it.
Pole of the magnet, and that's what's happening here. The magnetic field being created by that current.
There are many magnetic fields here. First of all, there's a magnetic field due to the current. Second magnetic field is due to the magnets themselves. Okay, there are two magnetic fields at work here. Okay, so listen to this part.
Strongest in the middle, and then it spreads out, it diverges, or it becomes weaker on the ends. Where you've got these poles
this is the
facing each
configuration in
other.
which it should be. The reason is, it should be aligned in such a way that the north is in the direction of the field, south is on the weaker end to get pushed in this direction. Agree with this? Do you guys get that? For the magnet on the right, magnet on the left, the magnet on the left to get pushed, it should be aligned in this way. The south end should get the weaker magnetic field. Can you see this? Is this clear? In the center, the magnetic field is stronger inside the coil. Yeah, so this it has to be in this way. But on this side, the south should get a weaker field because south wants to go this way, north wants to go the other way. Agree with that again? North also wants to go to the right. North is always trying to go to the right. So the magnets have to be oriented this way. Is this fine? It has to be south, north, north, south. If you rearrange it any other way, you won't get that effect at least. Okay, okay. Look at this left hand side. Can you see the left hand side here? There's a north-south magnet here. Now, if you look at it carefully, the south end is on the weaker field. Can you see that? South end is on the weaker field. Okay, leave that. Look at the previous part. One second. If you look at this visualization, the field is stronger on which side? On the right hand side than the left hand side. Now, which direction does the North Pole move? Tell me, which direction? Right side or left hand side? North Pole goes to the right, in the direction of the field. South Pole goes in the direction of the opposite direction of the magnetic field. But here's the important detail. If you look at it, the magnetic field strength is weaker on this side and on the other side. So South Pole experiences a weaker field compared to the North Pole. North Pole experiences a stronger force. So it goes in the direction of this thing. If we reverse the direction of both the magnets, will it move in the opposite direction? Now, if you reverse it, what happens? Tell me, okay, I'll take a screenshot of this so I can try doing this. This might not work. What happens if you flip it? Can you visualize it on your own? What happens if you flip it? One second, I'll try doing this if possible. Can you guys see this? I've stopped sharing the optimizing the speed for now. Can you see this? Is the North Pole going in the direction of the field? Yeah, North Pole goes in the direction of the field. North Pole always goes in the direction of the field. So the field direction is like this. Remember this, okay? Now, here's the idea. If you flip this, now if you understand, here the force is weaker on the South Pole in this direction. So the entire thing moves in this direction. Now, if I were to flip it, let's say we were flipping it to be north and south, north will be going in this direction. Agree with that? North will try to go in this direction. Okay, but then the force on the north will be weaker. Agree with that? Because it's in the weaker part of the field. Do you guys agree with that? Is the North Pole going in the direction of the field or just a convention? It's just not a convention. It just happens to go in that direction. Okay, it goes in the direction where the field gets reinforced. Okay, now do you agree the south will experience an even stronger field compared to the north because it's in the it's in the stronger field region. South is in the stronger field region. So if you flip this, if you flip these two, then you'll get the magnet will start flying in this direction, opposite direction. So you got to make sure that when you align them, you keep the north in the direction, you keep the north in the direction of the stronger field and not the weaker one. That's the idea. You keep the south in the weaker one. So we make sure, even if you flip it, it'll go in the other direction. So acts like positive and negative. Yeah, it acts like basically positive and negative charge. What if the NSS will be, and we flip the battery? If you flip the battery, I think we'll go in the opposite direction. That's all. It's basically like rotating the entire setup. Okay. Okay. All you need to understand is this basic idea that what you say, that the direction keeps changing. Okay. So listen to this part.
And that's what's happening here. The magnetic field being created by that current is strongest in the middle, and then it spreads out, it diverges, or it becomes weaker on the ends. Where you've got these poles facing each other, say two norths in the middle, they're feeling a stronger push than the souths on the outside. And if that push is in the right direction, it's gonna shoot straight through, like so. So now we know it works. Now it's time to play.
Okay,
I've got this facing each other.
The idea is, yeah, I think you got it. N is placed on the left here because N is stronger. The field is stronger in the center. So is it back? Yeah, yeah. Can you guys hear me? I think my internet got used up. Yeah. Sorry. 1 second. Can the magnets move if both the south poles are in the middle? I think so. It should work. Technically, it should work, but the magnet might fly in the other direction, opposite direction. That might happen. Yeah, that might happen. If you flip one of the magnets, nothing will happen. Nothing will happen. If you flip one of the magnets in the wrong direction, one will try to push it in the other direction. Other one will get forced in the opposite direction. It will be pointless. Yeah. Okay, with that being said, that was one video on that, and there is one more. So does S experience higher field or North Pole? In this case, we have made sure the North Pole experiences a stronger field. Okay, we have made sure that is the case. Okay, it did not be the case all the time. Now, there is one more demo, which is also fun. Oh, this link is not available, so I have to go to Instagram and find it myself. One moment.
Say two norths in.
No, what's happening is basically whenever there's a weaker field, there is a weaker field, right? So the force will be weaker, that's all. Force will be weaker. That's the idea. Yeah, there we go. Why is the internet so slow? You need it. Okay, this should work. Where are we? Yes, physics fun. Yeah, it's somewhere here. Okay, by the way, check out this YouTube channel. It's great. Okay, not YouTube, sorry, Instagram. This is really good. They keep posting some amazing things. Yeah, here it is. I found it. It's called a homopolar meter. Okay, so can you guys see the Instagram, this thing? Yeah, okay. The idea is, all you got to do is, and then put a stuck. It starts rotating. It's based on the same idea. It's based on the same idea. Earlier, you were keeping the coil fixed. Remember that? You're keeping the coil fixed. This time, you're producing a magnetic field such that you're applying the force on the wire this time, using the same idea. Okay? I'll come to this later in some time, but I just want to show you the demo of this before I can go on to that explanation. Okay? Yeah, you can check it out on your own. There's this YouTube channel also if you want. Okay? I'll go back because, yeah. Yeah, this video towards the end. I think I found it. What is it playing in the background? Once again, that video is playing in the background. Yeah, stop it. Yeah, good. Now, one second. This is going to take a moment. Yeah, there is something called circuit breakers. Do you guys know about circuit breakers? For fun, just an add-on. They work on this same idea. Okay, you've seen this in your house, right? Yeah, they work on magnetic field. Okay, strong currents and magnetic field. I won't discuss this because it's not really part of the syllabus. It used to be part of the old syllabus, so I just kept it here. It's just there. But the idea, it's a genius thing, okay, the way this works. It works based on this electromagnetic idea itself, where when large current flows, a strong magnetic field is generated, and that leads to something moving instantly, a switch getting closed because of large currents. What is the circuit breaker? If there's a large current, it has to break off, right? So there is a genius mechanism where a strong current through the coil make sure that it ends up pushing a lever or something like that, which internally disables. Yeah, it's better than a fuse because you can pull it back. A fuse has to be replaced, but a circuit breaker can be switched back again if it breaks. And there's a mechanism for it. It's like a fuse, but the thing is the wire doesn't break here. Nothing breaks here. It's just the contact goes away. It's like a switch. Okay, you can check that out on your own. But before that, I can discuss this. There's something called motor effect. Now, motor effect is there is always a force on a wire which carries current. Okay, it's called, common name is tripper. Yeah, it's called tripper in your house. Yeah. Oh God, Vivek. Okay, fine. Yeah. So here's the thing. You and Anish keep sending stupid things. Okay, wait. Yeah. So here's the thing. Let's say we have a wire which is carrying current like this in this direction. Okay. It has been observed that if the current is being carried in this direction, in this direction, the entire thing gets thrown in the other direction, perpendicular to it. Now look at it. Which direction is the magnetic field? Can you tell me? Which direction is it, up or down? Is the magnetic field up or down? That's all I need to know. Is it upward or downward? It goes from the north to south. Remember that. It always goes, magnetic field goes from the north end to the south end. In between the wire, in this gap, which direction is the magnetic field? Do you agree it's upward like this? Hopefully you agree with that. Now, the wire is carrying a current in this direction. Do you agree with this? In this direction. Everyone agrees with that? The magnetic field always goes from the north end of the pole to the south end, upward like this. That's what I meant. Okay. Yeah. Now, hope you agree that the current is being flowing in this direction, perpendicular to it, at 90 degrees to the magnetic field. It has been said that it has been observed that this wire experiences a force in this direction, in the third direction, like this. Or if I use a better color, in this direction, perpendicular to it. It has been observed that way. Is that fine? Why? I'll come to that in some time, but it has been observed. And this is called the motor effect. Is this fine? So perpendicular in 3 dimensions. Yeah, it should be 3-dimensional. This is a very 3-dimensional thing. Okay, very 3-dimensional thing. Okay, because of I think one person, Anish, I'm losing a lot of this thing, a lot of your messages. 1 second. Yeah. Vivek, 1 second. That can't happen. Vivek, why are you wasting time? 1 second. Where are we? 1 second. I need to do something. Done. Now, with that being said, here, Vivek, but you're wasting it. Anyways, so here's the idea. So if you have magnetic field going upward, and if you have the current flowing perpendicular to it in that direction, the force experienced by the magnetic field, force experienced by the wire will be in the direction perpendicular to both of them. Hope that is fine. Is it because vector cross product? Yeah, it's related to cross product. How many of you here have studied cross products and dot products already? How many of you know something about cross products and dot products here? I'll come to that, Anvita, 1 second. Yeah, most of you don't know. Now, this phenomenon is called motor effect. Listen to this. Wire, a current carrying conductor placed in a magnetic field experiences a force. Is this fine? Yeah, Anvita, I'll come to that. Yeah, towards the end, not today, towards the end of this. Okay. So this is called motor effect. Okay. Now I'll tell you why this is important. And by the way, if you reverse the direction of the current, the wire bends inward. The wire flies inward, not outward. If you reverse the direction, is that fine? Is that fine? Just saying the force will be in the reverse direction. That's all. And there's a reason for that. It's mathematical. The reason is mathematical. So there is something called the Fleming's left-hand rule. How many of you heard about it? Yeah. So personally, you can use it to determine the direction. Okay. Now the idea is the force will be in this direction. If the current is carried in this direction and the magnetic field is upward, the force is in this direction. They say you must use the Fleming's left-hand rule. To be honest, I personally hate this. Okay. I don't like it a lot. It's for kids. Okay, you don't require this. Okay, all you need is one rule. Once you understand the equations, you don't require this. Okay, Fleming came up with it for some reason. It had its uses, but you don't need to know this. Okay, there are some two amazing videos which will do better job at explaining this. Okay, without using Fleming's left-hand rule, and I will introduce them tomorrow. Okay, you will be seeing this guy. Okay, that is tomorrow. Is it fine? You will be doing Bharatanatyam. No, the Bharatanatyam won't stop. You will be using a right-hand rule always. Okay, there'll be a right-hand rule that will be using. But I'll tell you what it's going to look like. That's all. Okay, Fleming's left-hand rule, do not learn it. Okay, it will confuse you more. Okay, always you need to use the right-hand rule. Okay, I'll leave you with the equation. The force conductor experiences due to a magnetic field and a current, because it's carrying a current, is given by I times, I is a scalar, I is a number, times length, length is a vector, cross product with the magnetic field. Is this fine? I'm just saying it right now. Tomorrow I'll explain how to get this. Okay, how to get this and why it comes up this way. Yeah, this rule must have been taught, but that's why I mentioned it. It's taught in schools. Fleming's left-hand rule is taught in NCERT because they can't introduce this mathematics at a young age for you guys. Once you understand this, all of that is piece of cake. B is the magnetic field. B is the symbol for magnetic field, by the way. Magnetic field is using a quantity called Tesla. Okay. Unit is Tesla. How do you measure it? We have devices that rely on something called, no, there are many methods. There's something called Hall effect sensors. There are many methods, but there are many devices which can measure it. I is the current. L is the length of the wire. How long is the wire? Okay. This is secretively actually a law, a famous law of Maxwell again. One more law of Maxwell. Okay. All of these things are, by the way, we give so much credit to Maxwell because he was the guy who put together everything. Like he put together all the Faraday's work, all of Gauss's work, everything into 4 equations. So yeah, what is B? B is the magnetic field. B is the symbol for magnetic field. Okay, B is the symbol for magnetic field. It's a vector. Fleming you don't have to study, but Fleming is there in your school textbooks, so just know that there is something like that. You don't have to study it. It becomes obvious once you understand this. Is this fine? Yeah, the previous slide is nothing much here. Yeah. Please read about this after class, okay? Then you'll get an idea. As far as I have understood, you guys don't study anything after leaving the class, okay? Probably you'll test the books only to do the DPP. But after that, I'm really skeptical whether you'll actually look into something. So please look into it. Vivek, why do you waste time like this? Yeah. Yeah, I know. Now, Anish is here. Anish is here. 1 second. Okay, so that's about it. Yeah. Okay, cool. For today, that's about it. Okay, nothing much. I'm sorry about the Python thing. I'll send the instructions cycles for that. 1 second. Shapey, what is that? Okay. Vivek, your problem is a weird one, can't be solved. Yeah. Okay, Anvita, cool. Just send it to me on the mail. Yeah. Nah, Mithil, I won't do that. I don't think so. I'm not sure. Let's see. Yeah. Okay. I think that's about it for the day. Please reinstall Python, Vivek, if that might work. But just try to figure out if there's something. It's always this glitch. Before the slide, there was this. Yeah. Okay. Anyways. Will you be conducting online coding after it or something? The thing is, I'm not sure. I'm not taking it as a class as such. I'm going to give you a bunch of exercises, okay, to try with it, and eventually learn how to deal with them. Okay. So once you have an idea, once you try those exercises, my hope is that you'll get better at it. So that's my plan. I can't take classes as such specifically. That won't be possible. So I'll be giving certain ideas like try this, try that. And during those 15 minutes, I'll ask you to present what you've done. Okay, I'll give you a program. Try it. Whoever wants to present, they can present and clarify and debug. Okay, because computer science is all about spending time on it. It's not about that class. I've seen people take classes and not end up doing anything with it because you forget it. Computer science about is it's anything for that matter, whether it's experimental, anything experimental and this thing. It's about spending time with it. So you have to spend about 6 hours, 7 hours on the computer coding, and then you get that feel for it. You'll understand what I'm talking about. Yeah. Is Python 96 KB or 26? The 26 KB file, it's a heavy one. The python.exe file is about 96 KB kilobytes. It's just the exe file, that's all. What is this slide? This is just telling you that if you reverse the current, the magnetic field will be directionally, the force will be flipped, force direction will be flipped, that's all. Okay. Yeah. Anything else, guys? I'll tell you the exercises for now. Nidhi installed 2.7. I'll send you the link for it if possible. I'll send the link for it, 2.7. Others, send me the issues in a screenshot. Send me a screenshot of the issues. Okay, I'll be able to clear it up. How is typewrite function used? Typewrite is, I think, look at the cheat code. Look at the cheat code. It tells you. I think as far as I understood, just type pyautogy.typewrite and then write down whatever you want to type and give the time, how much time it does. It should feel like a human being, right? And give it 2 seconds delay. The advantages, have you ever come across those captchas where you have to type something? And by the way, computers, there are software programs which kind of figure it out that it's not a human being who's doing it based on that. Because of the typing speed. Human beings have a particular typing speed. And they can detect this if the typing is uniform every few seconds if you type it. So you can't use it there, but at least you can trick them by randomizing that also, where the keystrokes are more like human being. I've done crazy things like that, so that's what I'm saying. Okay, yeah. Download another. Oh, Anvita, there are 2 Pythons in your, 2 permaries in your this thing, PC. Okay, fine. That's an issue we'll have to resolve. That's slightly tricky. It's not that simple. Okay, some other time. Yeah. Just send me the screenshot. Just send me the screenshot. I see this thing, this coding thing, right? It might take a long time before I help solve all of the issues. I'm just going to do a bunch of exercises, throw a bunch of exercises. Okay. Yeah. Next, my goal in the end is to do the following exercise. Last final one is to automatically play Chrome's broken game is there. You know that game of Chrome, right? In Chrome, the dinosaur game. Yeah. To play it automatically. That's the end goal of the exercise. The dino game. Yeah. To play it on its own, without human intervention. That's the goal. That can be done very easily, actually. It's not that hard also. Okay. So let's see. Yeah. Try many things. Yeah, the offline game. Yes. Yeah. The one very good. Yeah. So cool. I think that's about it. Anything else? Anything else? Will you give exercise? Yeah, I'll tell you. It'll be simple exercise. I'll just tell you what to do. Write down simple codes and try it out. That's all. Okay. For Vivek, the issue got fixed. Reloading must have worked. Probably. I don't know. Yeah, I'll upload the instructions. Yeah. Murali, yeah. Sunday, is it fine? Can we discuss on Sunday that thing? Sunday would be great. The next one will be probably tomorrow. We'll look into it. I'll just tell you what to do tomorrow. It's not a lesson as such. I'll just tell you some exercises, what to do, okay? On the coding side. Yeah. Yeah, I know. Satvik, it's a little bit differently on Mac. I know. Okay. You changed it. You messed it up. Okay. Slightly different on Mac than what you said. Mac, it's already installed. Python comes installed on Mac, by the way. Python comes installed on Mac, always. On all Linux systems also. Sumedh, your issue is a weird one. I need to personally look into it sometime. I think so. It's 2.7. There's a possibility, Satvik. Because I think it's usually they install 3. If it's a new system, it'll come with the newest version of Python. But if it's an old one, about 1 year ago, 2 years ago, Mac is very old, then it's probably running 2.7. But 2.7 is good. It can do stuff. Can't be command. Yeah, 0.5 is possible. You can even enter decimal values. It'll take it. 0.5 will work seconds. Just type 0.5. That's all. It should work. Okay, cool, Satvik. That's fine. Yeah. Once you install Sublime and Python, you're supposed to connect them. By the way, these instructions don't work for everyone. Okay, everyone has a different system, and you can install 2.7. Yeah, you can install 2.7. You can try installing 2.7 to try these exercises. That'll work. Okay. Yeah. Okay, nice. Anaconda also was there. Okay, set of lines. I mean, good. Work for me. Okay. Shashank, why do you need it? I'm not going to accept anyways. What is the cheat code name of the website? Just search the word PyAutoGUI.
No problem.
Once again, search PyAutoGUI. Okay, PyAutoGUI dot code sheet, a cheat sheet. You'll get it. Yeah, I'll give you the instructions for Sublime Text. Yeah, I'll send. I'll try preparing it. I'm quite busy with other batches, so that takes my time. Yeah. Morali is eating chakuli. Ah, no. Okay, fine. Nice. Good stuff. This thing. Shashank gets PyAutoGUI. Anyways, just give it a shot. I'll tell you the exercises, what you could try. Just to see. One more thing I need to just highlight. These Python things I'm telling you, it's on your own. You're on your own eventually. Okay, I'm just giving you the initial push to look into certain things. Okay, and enjoy. You can try, Amit. There are other modules for that. I'll teach you how to access the internet directly through Python. That also I'll tell you, because that is very important. That is a module I used long back to keep checking my results on a website. So to type my password, type my name, log in, and check out everything. I'll upload the steps. But the steps won't work for everyone. That's what I'm trying to say. The methods are different, so you need to have some understanding of why we are doing each step. Otherwise, it's pointless. In fact, since I don't have a computer science background perfectly, I don't understand most of the steps myself, why they work. So I always Google on how to fix things if there's an issue. And that's the case for everyone, I think. Even the most experienced programmers, they end up Googling at the end of the day to find those little bugs. Oh, I'll change the chat to everyone public. Sorry, I forgot about that. Yeah, now it's public. Yeah, I've changed the chat to public. That's done. I'll be teaching you a module called Selenium. Once you understand Selenium, you can automate Chrome. Chrome also is possible. There's a module called Selenium. Yesterday installed PyAutoGUI, right? There's something called Selenium. Selenium is the most commonly used automation system that's out there. A cheat sheet of this thing, Satvik, a cheat sheet of PyAutoGUI, not Python, PyAutoGUI. That's a module. There are many others, but I'm talking about PyAutoGUI cheat sheet. I'll try to find it if possible. 1 second. see this, there's something called, for every program out there, computer science program, there'll be always a documentation. And this is a documentation for this. Okay, I'm sending it to everyone right now. You'll be able to see it. That's a cheat sheet. Okay, so you can read the documentation of what codes you can write, what you can write. Now, this is not Python. What you're doing exactly is not, what you're writing is Python, but you're using some module, extra module from outside. There are some crazy modules. There are some modules who can do much more crazy things. There are modules which can control satellites, television, and many crazy things. This is just one of the modules which I showed yesterday. You can install them and do some crazy things. I've had modules which can talk to, do voice recognition on command. I've written a code before this where you say something, like I've connected Google Assistant to it and then done some crazy things. So it's possible. That's my point. So there are many things. If you can connect Google Assistant, you can give voice commands to it. Yeah. Okay, I'll be making a move. Bye-bye, guys. Take care.
Shall we start with the classes, students? Ready? Yes, all are ready? Okay. So now, okay, break is it, Ashay? Okay, you take a 2 minutes break and come back. Quickly drink water and all that, whatever you want to do. 2 minutes only, but you should be back after that. Okay. Because I also have to finish. I have to finish this one progression chapter, but I don't think I'll be able to finish. Okay. Yes, quickly 2 minutes. Take and come back. Okay, yes. Okay, Rahul, I'm not sure what about yesterday's this one that you will get information from there. And Anika, yes, we will do it. Okay, but I before that I'll just give you some hint, and it will be better if you try it. Okay, because it's simple based on summation of AP or some form of a AP. Okay, that's what we have. Anyhow, let us come back to today's class. But before that, before I start with the progression chapter, I had not finished the discussion part of the DPP, right? So are you able to hear my voice clearly? Is it too soft? Okay, you're able to hear. That's nice. Okay. So now let us quickly discuss the DPP, students, because I had not discussed. First one I'll not discuss because it was very simple. Now I'll be going for the second one. Okay, second one solutions we will discuss quickly, and then I think okay, I think there is a little bit of okay. So anyhow. Just give me 1 minute, students. Some annotations are there, so that's why I'll just click that. I'll open it file again. Okay, so just give me 2 minutes, because just now I had a class. Because of that, I just missed that point that I had to just erase that annotations whatever I had used. I just missed that part. Okay, 1 minute. Just give me 2 minutes. It's here itself. I'll just open it. Okay, Ketan, I had told you yesterday, you don't have to explain everything. Only the one few steps I said. I didn't mean that you have to write entire thing. Okay, yes, it was told to you clearly. Okay, yes. So now let us come back to this. Okay, 1 minute. Okay, so no, it won't be. It will like yesterday. Okay, it won't be like yesterday. Don't worry about that. Okay, just 2 minutes, students. It's done almost. Okay, so now I'll be sharing a file. Okay, it's stayed. So now quickly let us come back to this. Okay, yes. Okay, Ketan. Then you have to clarify that with the sir only, because it was just told like just what was the no, it was not mentioned, because 5 grade it was 5 points for the question, means at least you should have 2 steps, right? I didn't tell you to explain entire answer. I have told you clearly regarding that. Okay, Anvita, we will come back to that later. Now let us finish this DPP of polynomials. Okay, just give me some time to finish this. Let us quickly finish this. Okay, DPP of polynomials. Again, I'll not be discussing in detail, students. Already solutions are there. I'll just briefly explaining you the concept, and then we will be moving on to the this one, progression chapter. Okay. Yes. Now here, can x square be a quotient of the quotient in the division of x power 6 by a polynomial? I have not read the other part of the polynomial. It is there. Don't forget, by a polynomial of degree with the 5. Okay. Now please understand, when the degree of the one polynomial is odd, another one is even, you can get only the even degree polynomials. Okay, so you can't have the polynomial with the or this one even degrees here. Okay, you should have a odd, because 5 minus 6, sorry, 6 minus 5, the answer is 1, which is an odd degree, right? So you have here even degree polynomial, which is not possible. A quotient cannot be with the cube, this one, okay, square here, because see here, the difference between the degree of this polynomial and the next one degree is 5, so it is difference is 1. So the maximum possibility for the quotient is the power 1 or a linear equation, okay. That has to be there. It can be asked, okay. No, Shashank, actually solution won't be sent. We will discuss, since we are discussing here, you should be able to do these kind of problems. That's what is expected. Okay, now let us come back to this. What will be the remainder and the quotient in the division of ax square plus bx plus c by px cube plus qx square plus rx plus s? Now please understand, when you observe that this polynomial here, okay, you can observe this is of, okay, this is of odd degree 3, and this is of second degree, or a quadratic equation, right? Okay, yes. Yes, Anvita, that will be given to you, but we are discussing the solution so that you will not have any problems for the exam, okay, so that you will know what are the answers, or at least how to do it. That is why we are discussing here. That will be done, don't worry, it will be uploaded. Okay, yes. No, I have not posted this solutions in this one, because you are supposed to do it, right? So that's why. So that now let us come back to this. Now you can observe the degree of the divisor is greater than the degree of the dividend. That is why you can't divide the given polynomial by that divisor. So your answer should be quotient is 0 and the remainder will be the dividend itself. Is that clear to you? So that is what we have. Or you can write either dividend, or you can write this expression itself. Okay, that is ax square plus bx plus c. That itself you can write. Okay, next, if on division of polynomial p of x by polynomial g of x, the quotient is 0. Okay, they are asking again, what if suppose the quotient becomes 0, then Shashank, it is yeah, it's a old DPP, but I had not discussed the solutions of this. Okay, that's why I'm discussing. Okay, but it has been not. I didn't get after that there was a long break and all that. I got only two classes in between. That's why. Okay, now let us come back to this here. Okay, now please come back to this. It's a quotient is 0. Then what is the connection between the p of x and the g of x, or what is the relationship between the p of x and g of x? Now, if you want here, you can observe clearly. This question is nothing but it's another version of the second question. Yes or no? Here you had quotient as 0 itself, and the remainder was the dividend itself. Same concept actually, but the question is asked in other way around. Other way. So what is your answer here? The degree of p of x is less than the degree of g of x. That is why you have this answer. Okay, because the remainder is also 0, they have said. So you can have it. Next, here the fourth question. If on division of a non-zero polynomial p of x by g of x, the remainder is 0, what is the relationship between the degree of p of x and g of x? Now let me see, if the degree is equal, you will get a constant polynomial, not the 0. Okay, that is why you can't get the quotient as 0. If the quotient is 0, it is a 0 polynomial. It's a division of polynomial by polynomial, right? It is a 0, they are saying. So if you are having the degree of the g of x is equal to degree of the p of x, you will get a constant number, non-zero constant. Okay, that is why that case is not discussed here. Okay, now let us move on to the next one. Yeah, okay, yeah, degree of the p of x is greater than g of x, Anvita, then in that case you will get a non-zero quotient. Okay, you will get a non-zero constant. Okay, so now in this let us come back to this. Here they are saying on the division of non-zero polynomial p of x by g of x, the remainder is 0, then it is nothing but the case of factor theorem. So the remainder becomes 0 when the g of x is a factor of p of x. Apply that and you will be able to write it. Okay, that's it. So now they are saying, can the quadratic polynomial this, that is they have given kx square plus kx plus k, have equal roots for some odd integer k greater than 4? Okay, some odd integer. Actually here, let us come back to this. For some integer it is better, okay, rather than odd integer. Some integer would have been better, because here k value is 4, it's not an odd. Okay, some integer, okay, it can have another meaning also. Okay, here let us come back to this. Whenever they ask for what value of k it is possible, we can go for b square minus 4ac is equal to 0, because the roots are real and equal here. So b square minus 4ac is equal to 0. You get a is equal to 1, b is equal to k, and x is equal to k. Substitute it in this equation here. You will be able to get k is equal to 0 or k is equal to 4. But they are asking it is k is greater than 1. Using that, you will get k is equal to 4. Okay, that's all we have. Okay, next we'll move on to the next one. Given that root 2 is the 0 of the cubic polynomial. Now you know, if they have given root 2 as the 0, there are two options for you. Okay, one is going for the long division, or else I have taught how to factorize, isn't it? Didn't I tell you how to factorize these kind of cubic equations? That also can be used, but you know, since there is an irrational number, you may find it difficult. So easiest one is, since all of you are well versed with the long division, you can go for it and you will finish it within minutes, few minutes. Okay, not even few minutes. I think some of you may finish it within 1 minute. So that you can do, x minus 2 is the factor you take and divide this polynomial by that x minus 2. Okay, once you do that, you get a quotient here, that is 6x square plus 7 root x plus 4. That has to be factorized and you will get the answer as x is equal to minus 2 root 2 by 3 and x is equal to minus 1 by root 2 after factorization. Now if you find it difficult to factorize, you have an option. What is that option we have? You have x is equal to, okay, it is this way, x is equal to minus b plus or minus root of b square minus 4ac by 2a. This is also possible. If you are not willing to do this factorization, you can always do this method. Okay, yes, yes, you can calculate first b square minus 4ac and then you can go for the other factorization. Is it fine? Okay, any doubt regarding this? No, right? I am not going in detail, students, because we will not be doing that problem. You have already done, just I am discussing the solution. Okay, yes. So now let us move on to the next one. Here, another one. They have said, find the value of, okay? Find the value of k so that x square plus 2x plus k is a factor of this given polynomial. And also you are supposed to find all the roots of the two polynomials. So you can see here, x square plus 2x plus k, this is not a normal polynomial. There is a constant here. So what we can do is, yes, Nidhi, what is the doubt? We'll try to avoid paper pen because we can't understand who is doing what. Okay, so you may have to answer it accordingly. Like what I'll try to do is, your final answers only I'll try to ask. Is that okay? Fine. Okay, yes. So now let us come back to this so that it will be easy for you to write the answer. Even if you have to write the equation, see you can write it like this. Suppose if you are writing this x square, no, you can write it like this: x2 plus 2x plus k. This is fine. This is fine. Okay, don't write it as 2x because this 2x is different and x2 is different. x2 can be considered as x square. Okay, that is okay. Fine. Not in all the cases, Vivek. It is only in the few cases I am saying. Suppose you are supposed to ask. And also there will be graph. I am not saying you have to plot the graph as such. Okay. Oh, you can write. If you don't want to write x2, no, you can write this x square also. This is also fine. Okay. That's fine. That also can be done. Okay, yeah, but Ketan, now you know what is the condition. We can't have all that. As usually it was like, that kind only. And if you're typing in Schoology, there is no much options for that. Again, it will take time if you have to do all these math kind of things. Okay, so anyhow, let us come back to this, students. Now, when it comes to this one, graph questions, in the sense you may have to write some points or something like that, lowest point of the parabola and all that. But please remember, I don't expect you to do that completing square entire method and all that. Maybe if I ask you also, I may ask you the last part of the completing square method. I don't want you to explain entire steps for me because you will not finish if that is the case. Okay. Yes. So that is there. Yeah, but the Navya problem is what, there are many of them who are using phone and some are there who are using laptop. If we tell that you can click the picture and send, they will say we are using laptop and we can't send this one. Okay, yes. Yeah, you can write only the 1 or 2 steps. Okay, not necessary for all. 1 mark directly the answer, whatever is there. Okay, yes. Okay, yeah. Okay, let us come back to this. So that is what is the problem. No, we are not able to finalize regarding this. Okay, let us see what happens. Okay, yes. So let us, okay, yes. That is easy, I know, but some of them are not ready to do that. Okay, yes. Yeah, okay, you don't have to worry about the enough time. There will be, but even if I don't give you, you will be asked only the final answer or something like that, so that you will not have to struggle. Okay, yes. Now let us come back to this, but your time will be 45 minutes only. I can't do anything with that part. Okay. So now let us here. Okay, here please remember there is a k here. So what you can do is, instead of going for factorization, I have told you, this actually can be solved using one more method also. Some of them try with the division algorithm, but compared to division algorithm, the long division is the easiest one. Okay, easiest one. So go for the long division, and since you know that it is a factor, equate the remainder to 0. Okay, when you equate it, you can compare the coefficient of x. So using coefficient of x, you get k is equal to this answer. K is equal to -3 is your answer. K is equal to -3, and after that they are asking you to find the remaining roots also, find all these zeros. So what you have to do, you have to come back to this. You have to substitute what is the value of k in this quotient. Okay, in the quotient you substitute what is the value of k, and then you will get a quadratic equation there. Factorize it and get all the 3 roots. Okay, yes, that's how you do it. Okay, yes. So now let us move on to this one here. Okay, yeah, Murali, now I think there was one problem I think I had done in the class. Can you please refer that? I don't know which was that, something like that or similar to that. Just refer some one problem. I think I had done it, but then most of them agreed that long division is a very simple one, so I said go for it. So now let us move on to this. Given that x minus root 5 is a factor of cubic polynomial, if not that, maybe tomorrow I have test discussion. No, we'll do it that time. Okay, if you have that kind. Okay, now you don't have to bother about the method. What is important is I want the last one. Okay, last answer. So you can use whichever method you want. And remind me tomorrow. I think one more answer, this one question from yesterday's discussion was pending. If I get time, surely I'll discuss that also. Somebody was asking how to identify the graphs using trigonometry. That okay, that also little bit discussion we can have. Yes, you can write root 5 as root 5. Okay, like this. Don't have to write like this. This is not necessary. You can write like this. Okay, now let us come back to this. Given that x minus root 5 is a factor, cubic is this one, find all the zeros of this polynomial. So now what you have to do is, you are supposed to take again long division. You can do it, is very easy. You do the long division, you will get the quotient. I know quotient is missing because it is somewhere here. Okay, that long division is very difficult to type, students. That's what happens. It's really difficult. So usually we prefer to scan. Okay, so the quotient is this factor here. We know that. Okay, see, whatever quotient you get, that will be the factor. Another factor you get here, x square minus 2 root 5x plus 3 is also a factor, and then you get it like equal, put it equal to 0, and then there is no necessity that you have to use this. If you are able to factorize, you can go for the factorization. Okay, if it is possible, please understand, if it is possible, you go for that factorization. Otherwise, what you can do is you just do this, make use of formula, and then you can do it. Okay, yes. Now, who is that typing so many times? Multiple choice. Okay, we'll see that, Mithul. Okay, yes. I can understand. I can understand if you write it once. Okay, yes. Now, I'm rushing with this because I have a progression left there. Okay, that's why. Okay, progression has to be completed. For the values a and b, okay, for the values a and b of the zeros, this one here, x q of x is equal to x cube plus 2x square plus a. Here, also the zeros of this one. So here you have to understand whatever is there in q of x is a part of p of x. Okay, so the zeros of the q of x are the part of the p of x. Now please understand, this is the cubic polynomial. Okay, this is a cubic polynomial and this is the 5th degree polynomial. So there is a difference of 2 roots. Okay, these 2 roots are not the part of q of x. Please understand, you have to remember that 2 roots are not the part of this one. So using long division, find out what is that factor. another factor. Okay, once you get that another factor, factorize that and get whatever is the root. Now you may tell me that there is no a and b, right? So what you do is, whenever you are doing division, see this quotient is in number form, but your remainder should be equal to 0. Why? Because you know that q of x is the factor of p of x. Why? Because all the zeros, okay, all the zeros of the p of x are the, what is that, are the part of the this one p of x. That is why we can equate it to 0. Once you do that, you can equate the coefficient of x squared to 0, you can equate the coefficient of x to 0, and then finally you can equate the constant to 0. So using that, you get a is equal to -1 and b is equal to -2. These are the two, this one, and then go back to the quotient there, factorize that, you will get the another two zeros which are here. Okay, x equal to 2 and x is equal to 1. So this is what we have. Next we'll move on to the next part. So here, find the roots of the quadratic equation using quadratic formula, each of the following. You know what has to be done. First thing is, you have to go for PD is equal to b square minus 4ac. So first thing, you find this, decide whether there is a real root or not. If there is no real root, then you can go for the complex root. Okay, now that is here it is done first. There is a 32 here, 32 is greater than 0, so you can proceed further to find the root, and your answer will be 3. Okay, I'm sorry, here x is equal to -3 by root 2, sorry, 3 root 2, and then you have x is equal to root 2. This is how you can factorize. Okay, yes. So now here, actually the second question I have not given, I don't have the solution here, students. But first thing is, whenever you have to use the quadratic formula, first find out what is delta. Okay, now delta is nothing but b square minus 4ac. You get 45 minus 40, you get 5. Then you can go for x is equal to minus b plus or minus root of d, or delta, whatever you call it, d divided by 2a. Use that and find the roots. Okay, this is what you do. Next one, seventh one. If you observe, I think in the notes, I mean, in for your DPP, I have given -5. Actually, I wanted to give you +5 because you will have an experience with the complex root. But anyhow, since I have given you -5, I'll do that here. Okay, it is okay. Anyhow, it is not working. I'm not sure what happened. Okay, okay, leave it, students. Just this one can be completing square method, right? So in the completing square method also, first check whether it is d is greater than, okay, d is okay, please check whether d is greater than 0. Okay, 1 minute. Okay, it's not writing. I'm not sure what is wrong with mouse. Just give me 1 minute. Okay, but you can understand, right? Whenever you have a completing square method, students, here, okay, what we do here is, first we divide this entire equation by 2. Okay, if you have a +5 also, it is okay. +5 means you will have a complex root. If it is -5, then you will have a other one. Okay, so that is what we have. Okay, so now let us come back to this. Yes, Anika, marks has been not given. Okay, yes, so that's the reason you didn't get your marks. Is it okay? Fine. Okay. I have given you the hint. If you have this one, how to write, isn't it? Then why you are worried now? I have given you how to write it if it is like that, right? Then why are you worried about that? Don't worry. Okay, you will be able to do it. Okay, yes. Now anyhow, let us move on to the student. Suppose if you have a completing square method, okay, if you have a completing square method, please remember you're not supposed to keep any coefficient in that part. Okay, yes, now it's writing. Okay, so here it is, I've divided, and then you have here 3 by, okay, I don't know, it's not coming, students, just Okay, some problem is there with this. Whatever I'm writing is not visible in the screen. That's the problem. Okay, it's just coming for some moment and then just vanishes. Okay, anyhow, just let us leave that part. But anyhow, I just explained to you. You just divide this by x 2. You will get x square minus 3 by 2 is equal to minus 5. Okay, and then you can continue with the this one completing square method. But remember, you will not be able to do it with that. But still, what I wanted to you to do is I wanted you to have a complete complex number answer. I've done that. Okay, yes. So but if it was minus given in the, I think most probably in your paper it was given as a minus 5. Okay, so in that case divide it and you will get the proper answer here. Okay, you will get the real number. So okay, next we'll move on to the next one. Okay, I think nothing is. Are you able to hear me, students? I am not sure. Okay, with the there is a one question with the complex number 10-second. Okay, yes. So I think there is some problem. Oh, just to give me 1 minute, students. I think there is some problem with the laptop. It's just not moving at all. Pages. Okay, just let me start with the new. Okay, yes. Anyhow, Microsoft. Okay, yes. Because it's continuously I'm working with it from almost 3 hours, I think 3 to 4 hours. That's why it is bit stuck. It's too hot also. That's why I think just 1 minute. Okay, anyhow, let us continue with that part. The next question is are you able to see the black this I mean file shared, students? Are you able to see it? I don't know whether you can see. No, right? Okay, yes, is it? What are you able to see the this one? Whatever solutions I have displayed. No, I don't know. It's just stuck. Oh, the wallpaper. Okay, yes. I'm sorry. No, it is just showing wallpaper. I think it's not showing any share. Okay, yes. Okay, now again I'll share it once again. Okay. Just give me 1 minute. Okay. Okay, yes, it's proper now. Okay, I'm sorry for the delay. It just got stuck, students. So I could not do anything there. Okay, let us move on to this one. Okay, here. Okay, all the Zing notations are from the previous class. I'm sorry. Okay, now let us continue here. So I was telling you here that we can divide this by 2. So you get x square, then here, okay, you get here, uh, you get 3 minus 3 by 2x minus 5 is equal to 0. This is what you get, and then you use the completing square method, do the calculation here, you will be able to do it. Okay, next here again they have given the same thing. You can check whether b square minus 4ac exists and then do the completing square method. Okay, then they have told you sketch the separate graphs. Okay, separate diagrams they have told you. So in order to sketch that, what you have to do is, it is 2x square. Okay, 2x square minus 4x plus 7. Okay, 2x square minus 4x 7. 2x square minus 4x plus 7. So you, what you can do is, I have given you a shortcut in this one notes. I don't know whether you have referred this one. Did you refer the notes, students? Did you find it in the Schoology, the polynomials notes? It's there in the Schoology. Okay, you can use that formula. I have given you there how to find the vertex of the parabola. Okay, so that can be used if it is asked for the 1 mark. Okay, you'll find the lowest part of the this one point of the parabola. You can go for it. Okay, so you can do it. Now let us come back to this other way. If it is asked other way around, expression or something like that, you have to do it like this. Y is equal to, you have to take 2x square minus 4x plus 7. Take 2 common, x square minus here 2x plus 7 by 2. Now what you do is, here this is the completing, yes, that only. Okay, you can go for it, or I have given it in terms of other way around, simple bit, little bit. Okay, yes. Saujanya, it was a part of it, isn't it? Complex numbers and all we have learned in this. Okay, yes. So here it is, this is done, and then after that 2 into x square minus 2x, here you can go for plus 1 plus 7 by 2 minus 1. Okay, so go for that and then complete it. You will get it as 2 into x square minus 1 plus 5 you get. Now suppose you want to find the lowest point, you go for this is equal to 0, you get y is equal to 5 and x is equal to 1. That's all you have to do. Okay, you don't have to do this in the okay, delta is not necessary, only if it is asked you can find out. Okay, yes. I don't, I have given, is it? Depends on notes, Nidhi. Like suppose if I have mentioned something like that, if I think there I have given the vertex, yes, obviously because the lowest point of the parabola, right? That will be included. Whatever little bit of notes and all I have included, no, that questions will be there, few. Because this is a part of it, right? So that's the problem, I could not finish it. This got delayed. Okay, next anyhow, then you if you don't want to do this, with this point only you can plot the parabola. If you don't want to do that, students, so what you can do is, you can go to this one, take this y is equal to, okay, this equation you can take, and you put x is equal to 0, x is equal to 1, all that you can do in this equation, you get a table, then also you can plot it. Okay, yes, definition and all I won't ask. Okay, definitions in the sense like I will not be asking you to define anything as such, because we have so many things to be done, so I'll surely not be asking definitions as such. So here this is what we have. So same thing has to be done here. See, remember, whenever x is minus with the minus sign, please see that you take minus 1 common. Okay, that's all. And then we have here the other one, the find the two zeros of the given polynomial if the roots are minus root 5 by 3 and minus root 5 by 3. What you have to do is, you know, this has to be taken as a factor, you get a quadratic polynomial. Now see here, in this problem actually you had two options. Either you could do it with the fraction, okay, just like this, or else you can take only 3x square minus 5. It is one and the same. Okay, you can do that and then do the long division method. You will get the the polynomials root as minus 1 and 1. You can do it. Okay, and then there was one error, students, in the this one there, that is, this was given alpha square minus beta square, and alpha and beta are real numbers, so I don't prefer you to go to the complex this one. I know you know it, I don't expect you to do it here. Okay, so just leave it. What happened? It's okay, no problem, you can do it. It was there, right? Okay, that's okay, fine. I'll just check, don't worry. Okay. I know, because of that only they asked me to check there. Okay, yes. 8 to 1, which is that 8 first one? 8 first one is minimum is 1.5. Okay, yes. Minimum is 1.5. Now second one, okay, yes. Yes, you can find actually, Ketan. I don't say you can't find it. You can find it. You can solve it easily using a alpha minus beta the whole square formula. But the thing is, like, alpha and beta are real roots. No, we have not defined them in the complex this one. That's why I said not required. You can just leave it. Okay, yes. Yeah, it is like correct. Whatever you have sent is correct, students. 2 root 6i, I mean 2 root 6i you get. Yes, correct. Many have sent the answer. Even Ketan, Shashank and all that. Okay, yes. Okay, yes, correct. That's what I said. That's why I said you this is imaginary. You can see I have written there. Alpha square minus beta square is imaginary. So that is why you just skip that part. It's okay if you have written, I'll be very happy to correct it. But the thing is, like, we are defined polynomials in real plane. Okay, yes. If you are willing to do that, you are welcome to do that, Murli. Okay, no problem. You can use biquadratic. Yes, that formula is yes. Obviously, you can do it. It's left to you, but okay. Be a little careful when you are using that root and all that. Okay, now let us come back to this. Okay, height. Again, this you have to do here. 1 by alpha square. 1 by alpha square plus 1 by beta square. Here take LCM here, so you get alpha square plus beta square by alpha beta the whole square. Then substitute alpha this one and all that, and you finish it off. Okay, yes. So substitute everything, you have a relation between them, right? Yes. So find out. Somebody actually, I wanted to tell you that this relations and all have the names. It has been named after some person or something like that. Okay, just find out. Do a little bit of study, students, because it has been discussed last year by sir in the class. I don't know how many of you belong to that group. Dinesh sir was, yeah, actually, yes, correct. So he has discussed so many things. Yes, I got the answer. I'm happy to see that. Okay, yes, not gods. Okay, yes, this is, yes, so this was there. He has discussed. Okay, yes. So he has discussed. But anyhow, you can just type the relationship between the roots and the quadratic polynomials coefficients. You get a lot of material there. You will be able to get it. Okay, yes. So this is the name of that. Okay, now let us move on to that. Next, they have given the height y meter of the water sprayed from the hose is given by this. Here, see, they have represented y is equal to minus x square plus 4x plus minus 1 as a height of the water. So it is, suppose that the hose is here, the water is getting spread like this. It is going like this, students. It is like that. Okay, so it forms a parabola here. So this parabola will have the maximum point. Okay, it will have a maximum, not the minimum. So what has to be done here is, yes, x is equal to 2 and y is equal to 3. You have to take minus 1 common and then use the completing square method to find it. Okay, understood? No, this is like real simple. This one. Okay, test or just answers. Just like I'll tell you which and all points has to be specified in the question. Okay, not much. I don't want you to do it. Okay, yes. So now graph, you know, again, this is with the modular, students. So what you can do is, first see, you can plot the graph of x square plus x minus 6. Okay, you can do this. You can plot this graph first using graph sheet and see that will be here. Dotted line will give you the actual graph of that parabola. But since we are using that modulus, this reflection will be here above the x-axis. Okay, you can just fold it. Yeah, as you said, Murli, yes, you can just fold it, or else you just find out this distance. What is the distance here? And same distance you measure here and take. That is another way of making it very simple. Okay, then you join this parabola slowly with that. Okay, you can find out what are these points here. Okay, accordingly you can do it, just like a folding it. Yes. It is not necessary, Nidhi, but it will be really helpful, because what happens is, in here apps and all, what these graphing apps are there, no, in that it is like directly it gives, but if you are plotting it manually, then these plotting the actual parabola and then taking the reflection will be much easier. Yes, okay. So that's why I said do this and then take this one. Okay, that's how can be done. But if you are using graphing apps, they will directly give you this. But remember, this is a part of the parabola, student. This was the root of that polynomial. X square, what you had here, no? X square minus x. Okay, I'm sorry, it is plus x minus 6. It's a root of that, but see, it is not the root of the actual function. Here what happens, f of x will be the combination of modulus function and the polynomial function. So this will have a certain range of value, not the roots. Okay, so that is what we can do it. Okay, now let us come back to this another one. So same way you do the other one also. Here also it will be easier if you trace the down part here and then take the reflection, folding it. Yes, you can do that tracing paper also, you can use it. It's left to you. I don't know how many of you have all those kind of things right now at this situation. Okay, it's I don't know, some places they are saying it is out of stock, that this and all. Okay, that's it. Shashank, instructions will be there. Okay, yes. Anika, I think DPP 1 was really easy. Do you really need the discussion? I don't think so, it is required. No, Nidhi, I can't ask you the modulus functions root, because what you know, when I give you modulus, right, it is a combination of two functions. Okay, this one. Okay, yes, it's a very simple DPP what I gave for first one. It's really simple. So here it is, the 1 minute 8th graph. Graph 8 is it? Which is that graph 8, students? We have two graphs here. One is here. 1 minute, students. Just one. I'm sorry for the disturbance. Okay, just somebody entered. Okay, yes. Anyhow, you don't have to plot. Somebody asked for this graph. See, please see this graph. Okay, and this is another one, second one. Fine. Okay, you don't have to plot anything as such. You don't have to plot anything. Just you will be asked certain points. Maybe like see here, the second one I had done that calculation, and then I have shown you that table value points are 2,3. That is the maximum. So I may ask you only this one. Okay. Okay. Yes. So maybe most probably by tomorrow. I think by afternoon it will be ready, Murali. Okay. Don't worry. Yes. Uploading may take time, but it will be ready. Okay, yes. How will questions of graph will see? What I may do is I may ask you the lowest to this one. Yes, so that is there. Okay, now let us move on to this one. Shashank, that and all you will come to know. Now let us move on to the progression chapter. Okay, yes. So that's it. I had asked somebody to do some work. I mean, like I think it was Shashank only. Is it Shashank? I'd asked you to find out something. I don't know whether you have done it. Okay. I'd asked you to find out something else. Something it was. No, test won't be like this one. Okay, yes. So what was that? I had asked you to do it. I had asked you to find out how do you get the sum of odd integers as n squared. That is what was my question. Do you remember right now? Any one of you? Okay, I think yes, that is what was my question, right? Do you remember that I'd asked you to find out and come back? Okay, so now tell me, how many of you have done that? Yeah, we will be, yes, I know, Rahul. That was Pete question and all that, right? I had asked you to do it, yes. Okay, let us do that. I was just waiting for the whiteboard to start. I don't know, today internet is a bit slow. I think I can find many of you also outside this one class. Every now and then there will be a reminder for me to admit students. Okay, anyhow, let us come back to this. Suppose you have this Just think that you have odd numbers 1, 2, 3, 1, 3, 5 and up to n. Okay, suppose you are supposed to find what is the sum of this. It's very easy. Just let me give you a quick proof for this. It is nothing but, see, what we can do is we can rewrite this expression as 2 into 1 minus 1. So that is nothing but, in other way, I'm writing 1 as 2 minus 1. And then I am writing 3 as 4 minus 1. So you can do this second one as 2 into 2 minus 1. And same way 5 as 2 into 3 minus 1. That is nothing but 6 minus 1. So same way you continue further, 2 into 3 minus 1 and so on. I don't know, last one, I'll just write it as, since it starts from 2 into 1, 2, 3, I'll just make this as n minus 1. Okay, it stops at when n, it reaches n. Because we have n numbers here. We don't know what is at n. So we will also take here up to n numbers are there. Okay. Yes. So now once this is done, okay, please understand, we can separate this two. So you will get it as 2 into 1 plus 2 into 2 plus 2 into 3 and so on up to 2n. And then there will be how many terms? Actually, there are n terms. So you will have n. Yes, you can use. Yes, you can do it. But just I'm telling you, this will be a little easier because some of them were struggling other day. Do this. Okay, so you get n. So minus n. So here 2 into this summation for natural numbers is n into n plus 1 by 2 minus n. So you will get it as, if you observe, take a LCM, 2 and 2 cancels, you get n square plus n minus n. So your answer is n square. So this is the summation. So that is why other day in the problem, it was p square plus q square is equal to r square. That is what it was, right? You remember? And then you had to find the, yes, values of that. You had to go for Pythagorean triplets, go for the minimum value. Okay, yes. Next, we'll move on to the next one. Next question there. Okay, yes. So let us do that. Okay, from the current slide. Okay, here is the next question. Let me remove all those black boxes. Okay, here is the next question. This I want you to try. Okay. Okay, 1 minute, students. This I want you to try this. Okay, just like this only. First one only, similar to that. Okay. You want me to show that whiteboard, is it? Oh, okay. I thought you have writing simultaneously. Sorry, students. I was little bit fast because of certain reason, because I have to finish the progression as soon as possible. That is the reason. Okay. Yes. So quickly write down. Yes. Fine. This is the one of the proofs. Let me tell you, it is the one of the proof. Not the this one. Okay. Okay, done. Shashank, which equation you're talking about? Okay, let us move on to this. Here, okay, this is your question for you to try. It's left to you. If you don't want how n into n plus 1 by 2 is, it's the sum of n natural numbers. You remember other day I had discussed a few special series. I had given you the sum of n natural numbers is. Do you remember this? We had just discussed somewhere in between the problem. Okay. Fine. Okay, this is the formula. Okay, this is the first formula we have discussed. First formula. We'll be coming back to the second and all that. Okay, now let us come back to this. It's very easy. So how to solve this? I'll be using again the whiteboard, students. It starts with x square, x cube and all that. Okay, so we'll do that. I think that's better. X square minus x cube, that is equal to 1. So here, so 1 is equal to, it is 1 is equal to x square minus x cube plus x power 4 minus x power 5 and so on. It continues up to infinity. Okay, so this is what is the question. So you are supposed to solve this equation. So how do you solve this equation? It's very simple, but you are supposed to identify this. Okay, the question is this: 1 is equal to x square minus x cube plus x power 4 minus x power 5. You need to solve it for x. Solve for x. So now how do you solve? Anybody can tell me? Any idea how can we solve? It is based on GP. And also you have to observe that there are two series here. Which are those two series? X square. Okay. This one is easier if you use one thing. I'll tell you, Amog, if you divide it by x, x will remain here. Okay, later on that has to be used, or else you keep x here itself, then also it will be useful for you. Okay, you can do it division by x, but instead of doing all that, you can just separate the plus and minus sign terms. So you will have it like this. Fine. Yes. So this is what we have, and then minus I'll take common. Then what remains? You'll have x cube minus becomes plus x power 5, x power 7, and so on. Fine. This is what we have, and you can observe that this is a GP. Even this is a GP. What kind of GP it is? Infinite GP. Okay, I'm not writing in words. That doesn't mean that I meant infinity. I'm trying to tell you that these both are infinite GP because there is no end for this expression. So now what you can do is here, okay, please understand, here you are supposed to find A. So A is here x square, and then R is nothing but x power 4 by x square, that is x square. Here also, okay, this point here A is x cube, and R is nothing but again x power 5 by x cube, that is x square. Okay, yes. Okay, that is also correct. You can do it. Okay, you will get the same series. Okay, yes. Anyhow, let us come back to this. You will use that. Now, what is this? It is the addition of GP, right? So, what is the formula for S infinity, students? What is the formula? You have A by 1 minus R, right? Yes or no? This formula you have for infinite S infinity. Okay, so use that here. A is x square, and this is 1 minus x square R, minus again x cube is the first term divided by 1 minus x square, because R is same for both. So now you get here, I'll continue with the black pen because there is a lot of confusion here. Okay, yes, so this is there. Here is the part calculation. Do the take all the LCM, all that. Okay, do the calculation. Here you get 1 minus x square. Okay. No, Shashank, it will give you a proper value. So get it here. You will get it as, okay, 1 minus x square is equal to x square minus x cube. Get it here. You will get 1 is equal to 2x square minus x cube. Fine. So now take x common, x square common. You get 2 minus x is equal to 1. So what are your values for x? X can be 1. Okay. X can be 2. The possible values. They didn't mention anything. Solve for x. So it is not equal to 0, surely. Okay, it can be plus or minus 1, and it can be either 2 also. Correct? Yes, all are getting this answer, or anybody else has got any other answer? No. Okay. Ketan, you have got only one answer. Is it x is equal to 1? No. Okay. Yes. Okay. Okay. How come it is different? Answers are. We'll get it as okay. X is equal to 2. See properly, students, here. Either, I mean, like here you have to be really careful. Okay, yeah. While telling, I'll say it is like equal to 2. It is not equal actually. It is x minus 2 is equal to 1, or x square is equal to 1. Okay, please understand that. That calculation has to be done by you. Then you have to calculate. X square will give you x is equal to plus or minus 1. Okay. And then how do you get complex values? 1 is not negative. Why do you need a complex value there? Is 1 negative? Okay, yes. Okay, Anvita has got 1. Again, how can, okay, then yeah, you can do it. You can, yes. -1 is not the solution. Okay, fine. Now what is your answer other than that? Yes. Otherwise, what you have to do is you have to solve the entire cubic equation. Then that will be another solution. Yes, you have seen. Okay, 1 plus or minus root 5 by 2 and 1. Okay, yes. So that will be another solution. If you are solving it like this, then cubic equation here will be like this. Here, suppose if you are doing that, then you have to start from here, this step. Solve the steps here. X cube minus 2x square. Then you will get the -1 here. I have changed the entire sign, students. Okay, I have made this positive. This will be my negative. Then when you bring it this side, here, okay. So I'm just getting it here and then changing the sign. It is minus, right? It becomes plus, equal to 0. So you have to solve this. Otherwise, okay, fine. Okay, 1 minute. If x is equal to 1, then this will be entirely, it will get cancelled in between, right? Yeah, yes. Varun, solve this cubic equation. Okay, yes, do that. Then what solution you get, you tell me. Yes. Equation you can't see. You will, previous equation. Okay, yes. Okay, 1.6. Okay. One is the correct answer. I can't see the equation. Okay, yes. Uh-oh, you are getting negative answer, is it? Just check, students. Okay, yeah. I'm checking because so many messages are sent. I missed a few of the things. Negative and positive. Yes. So do that. Okay, yes. Do the solution part of it. We'll discuss then. Because I can't see, everybody is like, they are so typing so many things. And yes, okay, x is equal to 1 and minus root 5 by 2. Okay, yes. I know, but some are writing this one. Okay, yes. Yes, Ketan, I'm looking into that. Wait. Yes. Okay, x is equal to -1. Okay. Did you solve that x cube minus 2x plus 1? Did you solve that question, students? Okay, yes, okay. I'm getting all in all the cases. What answer you're getting in all the cases, Shashank? Okay, yes. Okay, Mithul is getting somewhat some answer there. Plus or minus. Okay, yes, Ketan. Ketan, that number theory concept, will you please check it? What is it exactly? Okay, yes. Plus or minus 1. Shushruth, how do you get plus or minus 1? I mean, you have given slash. So I should understand like this. Okay, yes. So all are getting x is equal to 1 and x is equal to plus or minus root 5 by 2, is it? That all are getting? Some are getting x is equal to minus 1. Oh, what is it? All are getting different answers, students. I don't know how come you are getting like that. Okay, right now there is no condition. Okay, how do we do the? Okay. Yes, Nidhi, I read your question. Okay, I'll do that. Okay, wait for a minute. Okay, how can we access that? Check in the calculator. Okay, yes. Final idea is check in the calculator, but I don't want you to use the calculator. Kindly solve. You have taught, you have learned how to solve it, isn't it? Yes or no? Then how do you have a doubt of all that? Okay, yes. Then you should be able to do it, isn't it? Okay, if not this, then you have to solve it. How do you solve? X cube minus, I've got the answers. Many of them are saying their answers are. See, Varun, there is no condition given on X. You understood? No. See, suppose when you solve in X, do they give you anything? This is equation they are asking. There is no condition given in the X that's saying that it has to be in between so and so. You are getting, it is an equation, you have to solve it to get the value of X. That is what has been done. Okay? Yes. Okay, yes. So now, anyhow. So just use answers. Okay, answers were that. Okay. Shashank, finally you have reached. But what about others? What is root 5 value, students? Calculate and tell me what is your answer. Okay, you have got. No, there are others. Some who have sent the answer as 1 and then 1 plus or minus like that. Okay, then calculate the actual answer. Okay. You can see it now. Okay. Okay, yes, fine. No, no, that's okay. After your calculation, you are allowed to do that. Okay, yes. End with the plus one. Okay, yes. Okay, answer is not, okay, x is equal to 0 or plus 1. How can you get x equal to 0, Shashank? If you get x is equal to 0 here, there is no meaning for the entire equation, right? That is what they are discussing from that time. Isn't it? Yes or no? If you get x is equal to 0, what is the point? Okay, then you said Shashank Mn. It is not the other one. I know there are two Shashanks. Somebody has told me that x is equal to 0. Okay, Medansh, yes, it is correct. Okay, yes. Okay, so what is the answer to the equation? Anybody can tell me? Is it this answer? Okay, 1 minute. Here, x cube minus 2x square plus 1 equal to 0. This answer, or is it this x into x minus 2 x square is equal to 1 here? Is it this answer? Which one? Anyone can tell me? The first one, you have to solve it. Yes. Why that it doesn't work here? Anybody can tell me? Okay, this is your equations, cubic equation answer. Okay, cubic equation answer, and this is also actually giving you a cubic equation answer, right? Why it is not giving you a proper answer? It is also we are solving, right? That is also correct. Yes. Okay, fine. Okay, somebody is answering. One is okay, that is also somewhat correct. Okay, x square is not equal to 0. Okay, that is also correct. Yes, Navya, I think okay, one I think you have missed one root. Okay, yes, here. Yes, it's very important, students. The main problem here is it is the product of two numbers is into. Okay, the thing is here, the main problem what we have here is the product of two numbers is x a square into x minus 1. If it is equal to 0, then clearly you can equate this. But when it comes to into 1 is equal to 1, here product of any two numbers can be, okay, product of any two numbers can be 1. It can be a fraction, it can be anything. I can even have 2 into 1 by 2 is also 1. Correct? Okay, yes. Here, one thing. Let me tell you, Murli, here it is or. Usually what happens is here plus and minus we say in the case of actually this one, what is that, complex plane we'll say. But anyhow, here what we mean is either the first one is equal to 0 or the second one is equal to 0 we say as the product. Both is, that is also another possibility. Okay, yes, anyhow that is there. But anyhow, let me tell you, come back to this here. Okay, 2 into 2 here, so half, this is also possible, right, equal to 1. This is also another possibility. Or else we can have even 3 into 1 by 3 is also equal to 1. Okay, yes. Okay, okay, I understood now. Okay, from that time you were saying, no, I understood it the other way around. Okay, yes. So that is the very important. Okay, so that is why here this is the example for you, even in the case of quadratic equation. Tomorrow when it comes to this one, okay, please remember, even in the case of quadratic equation, you are not supposed to cancel and do this kind of calculation error. Suppose if I have x into x plus 1 is equal to 2, I can't say x is equal to 2 and x plus 1 is equal to 2. Okay, is it clear to you? I can't do it. If I do that, then it is wrong. It will not give you a proper answer. Is it fine? Okay, yes. Okay, yes. Now remember, so do this calculation, and what is your answer? You will get it, x is equal to 3 answers. So you, whatever you have got is this one. Okay, yes. So here, this one, Anika, what I meant is here, see, when we have something product into 0, then we can equate it. See, when I have x minus 1 into x is equal to 0, I can see these both are equal to 0, correct? It's easy. Okay, yes. I'll do that. Actually, we have, okay, Ketan, let me check that. Okay, I'll do that 1 minute. Just I'll check that and let you know regarding that. Okay, like this infinite, okay, 1 minute. Okay. Yeah, that's what in this one. Yes. Yes, correct. So here, that is what this, okay, yes, you can do like that only for infinite solutions are asked. Okay, yes, so in 1 minute. Okay, so many are texting, so I'm missing few of them saying students, so wait for some time. So here, please, yeah, if it is given like that in the factorization of equations and all, it is very easy, students. We do it, but when here, when I take this one here, that side, no, then what happens here? You have to understand one thing. In my case here, what was that? There is, oh, 1 minute. There is a little problem today, students. I don't know. It's laptop is too hot. It is because of this fluctuation in the network. That's why it is not working properly. Okay, just 1 minute. Okay. Here, when I did this, I took it like this: x square, 2x square, and then I took x square common, and I took it as 2 minus x. Here it is 1. No. So you just what we did is we are. It is better if you don't equate this to 1. X square is equal to 1 and 2x minus this is equal to 1. It is better you don't do this. But in the case of factorization, you can do it. No problem with that. Factorization in the sense we will have the equations, right? You have something like this: x into x minus 1 is equal to 0. In this case, yes, true. X is equal to 1 and x is equal to 0. This is correct, okay? Because there is a 0. Then in that case, we can clearly agree that the product of two terms can be 0, okay? Yes. So that's it. Okay. Okay, yes. So that's it. Now just to find the value of x, okay? So other actually, there is one slide. There is this one students. They had asked me one doubt regarding that. I'll just clarify it properly because I don't want to tell you half things and do some messy things here. Okay, yes, I'll clarify it to you properly. Which is the proper answer among the three? Actually, you get three. What is the reason for that? I want to tell you properly. So just I'll clarify it. Okay, yes. So okay, yes, I know one is not a proper solution there. Okay, and negative is also, it's not that this one. Okay, so that's why I'll just do that. Okay, fine. Yes, so that's it. Okay, yes, so that's what Ketan was asking me about, that itself, one concept. Okay, I just verified properly. Okay, yes, now we'll move on to the next one. So just keep the pending answer. You take down 3 answers you have, right? So just keep that. Okay, yes, so just I'll tell that. Ketan, if I just do that, let me tell you. Okay, the problem here is I can't just tell them like that itself. Okay, I'll just do one thing. Okay, yes, do one thing. I think it is better if I just try to in a better different manner. Okay, I'll just so that yes, 6 point, yes, that 1.64, yes, correct, I'll agree with that, but I want to tell you why one is not a solution. Okay, that is again the new concept, so we'll do that. Okay, yes, so that's it. So 3 answers, you keep it. Okay, students, that's enough. Okay, now we'll move on to the next one. Okay, yes, here. Okay, 1 minute. Okay, here. So this you can try again. The second one, it is there in your textbook, students, workbook, not textbook. I think it is workbook. You have it. So just try it out. It is again this one. Okay, now here, the special this one. How do you solve this special this one here? Another special sequences. Anybody can tell me which concept is used here? Okay. Oh, okay. 3 roots are there. 1 minute. Okay, binomial theorem. Okay, correct. So can I say that I can just directly use this one? Sumit, you get that a by b plus a by b square plus a by b cube and so on is equal to 4. That's this one question. Find a by a plus b plus a by a plus b the whole square. Okay, yes, that's the question. You get it in the textbook. Just do that. Okay, I think it's I'll just it's already time, students. Just I want to finish this at least. So that's why I'm just moving on to this one. I'll come back to this. Now let us quickly finish the derivation of this. So please remember students, here actually it comes from the binomial theorem. You can directly start like this. Okay, x cube, the difference of this cubes, x plus 1 the whole cube minus x cube. This will be equal to, if you are using expansion, excuse me, expansion of this, it will be x cube plus 1 cube plus 3x square plus 3x. This is what you have, correct? So simplify, minus x cube. So this gets cancelled. You will have it as 3x square plus 3x plus 1, okay, on the RHS. So this is the, I'm talking about the derivation of this. So we start with this difference of cubes because we are supposed to find the sum of squares. So we can use that here on this side, okay? So now let us continue how to do this further. So what we do is here, this one, okay, further, we just go on substituting x is equal to 1, okay? You can do x, instead of x, you can even go for n. I think n will be a better option because we use this one, right? What is that we say? Okay, you can use it. There is nothing wrong as such. You can use. So if you use x equal to 1 in that case, if I use n again, this will create a confusion. So let me go with this only. So if I take x is equal to 1, then the first one will be 2 cube minus 1 cube is equal to 3 into 1 square plus 3 into 1 plus 1. So same way continue. Take x is equal to 2 here. You will get 3 cube minus 2 cube is equal to 3 into 2 square plus 3 into 2 plus 1. Okay, yes. So next one, you continue further. Okay, further 4 cube minus 3 cube is equal to 3 into, here it is 3 cube, sorry, 3 square plus 3 into 3 plus 1. Like this you continue. Okay, see, whenever you have to find the sum of squares, we go with the differences of cube. Suppose you want to find the sum of cubic number, in that case what you do is you go for the differences of 4th degree polynomial. If you want to find the expression for 4th one, we go for the differences of the 5th degree polynomial because it becomes easy for us. You can see RHS, you have that square. That's the reason. Okay, it actually comes from the binomial theorem. I don't know again because I heard from the other batch that some of you were not there in the class when it was discussed by sir, or it has been not done. Okay, I'm not sure. Okay, yes. Anyhow, yeah, I have used the concept of mathematical induction. I have directly started with the identity. Yes, correct. That you can agree with that. But in case, see, even the binomial theorem is related to Pascal's triangle. Their coefficients are actually easily can be found. Okay, yes. So that's it. Actually, we are going for n plus 1 cube minus n cube. It is a kind of, I don't know whether you are able to understand. This is kind of, what you have seen like telescopic series, no, something kind of that. What is that we do is here we can cancel easily the terms so that we'll remain finally with the n plus 1 cube and the 1. That's how we have taken. Okay, x plus 1 the whole cube minus x cube. The difference is cubic differences between the two numbers. So now anyhow, okay, 1 minute. Somebody is getting admitted now. I don't know how come it is. Okay, now let us come back to this. So you take x is equal to 3. You continue this up to n. Okay, if you take it x is equal to n, then what happens? If here you will get it as n plus 1 the whole cube minus n cube is equal to 3n square. Okay, plus 3n plus 1. Okay, continue here. Once this is done, what you do is, since you have to find the sum here, okay, please do that. Okay, you are supposed to find the sum. That is why here okay, using the sum, you get it as n plus 1 the whole cube remains as it is, n cube. Okay, here this is there, no, this will get this will remain here, this will remain. What about this n cube? That will get cancelled with the previous one, that is n cube minus n minus 1 the whole cube is equal to here 3 into, that will continue. Okay, so now if you add all this, you can observe 2 and 2 cancels, 3 and 3 cancels, n cube and n cube cancels, so only this n plus 1 remains here. So using that, here you will get the answer as, okay, here you will get the answer as n Okay, what is this? Can anybody tell me? It is plus n plus 1. So n plus 1 the whole cube minus 1 cube, you get it, equal to, on this side it is the sum of, please observe here students, see if you observe here, this, see this part here, this part here is the series. We have the two series here. So using that, we can rewrite the expression here as, okay, as summation. Okay, I'll be going for k equal to 1 to n. That will be better, I think. So 3k square plus, because I'm adding numbers from 1 to k, n, and then summation k is equal to 1 to n, here 3k, and then n times, because there are n terms here, you will have n times 1. Correct? Yes or no? Do you agree with this part? How many are there? We continued up to what? X is equal to n, right? So how many times we had? We have n times 1 times, n times 1. Correct? So now you know the expression for this. So this you can go for the expansion. N cube plus 1 cube plus you can go for 3n square plus 3n minus 1. Plus 1 and minus 1 cancels. Here equal to 3 summation k is equal to 1 to n 3k square plus, here it can be the summation, 3 is there, don't forget, it will be the, this one, it is n plus 1 into n here divided by 2 and then plus n. Now if you expand, simplify this, you will be able to get it. Okay, yes, fine. This 3 doesn't have any summation value as such, or it doesn't have any effect of the summation. That is why 3 remains outside, and then n plus 1 into n by 2. Okay, fine. So from here, I think you will be able to do it. So you are supposed to keep this 3k square here only, shift all the other terms to the RHS, you will be able to do it. Fine. Are you getting the expression? Same thing, whatever is there here, n into n plus 1. So what did I do here is, Sakshi, I have expanded n plus 1 the whole cube using a cube plus a plus b the whole cube minus 1 cube as it is. This I kept it as it is because we are supposed to find the expression for k square. Bring that 3 outside later on towards the end. And here what I have done is, I know that summation k is equal to 1 to n. K is nothing but n into n plus 1 by 2. I have substituted that. But 3 will be outside because that 3 has no relation with this summation. Okay, that is what is there. So then you put here 1 n here. Okay, yes. So Murli, you have done same thing, is it? Or you have used other method? That's nice. Okay, after this, keep only 3 kx square on one side. Shift all these 3 into n plus 1 into n by 2 plus n to the LHS. Okay, do that. LHS you have to take it to the LHS and then do it. Summation will remain as it is, because see, we are supposed to find 1 square plus 2 square plus 3 square plus and so on up to n square, correct? Okay, yes. Plus n in the last, because see, can you see this 1, 1, 1, how many times it has been repeated? I started with x is equal to 1. I have completed up to x is equal to n, right? So that's why there is n times n, 1. That's the reason. Okay. So are you able to do this, students? What is your expression you get there? None? Okay. Try with the 4th degree also at home. Okay, yes, Ketan. You get the expression 2nq plus 3n square plus n. Okay, correct. Then you can go further for factorization. Just separate that middle term 3n square as 2n square plus n square. Okay, yes. Try to do that or something like that. Okay, I think denominator is there. You are getting 6 as the denominator. Okay, yes. 2 as the denominator. 6 you should get. Don't forget this 3 is there, students, here. See, 2 is from this side. Yes, I understand. This is 2 and then there is 3 here. See, this 3 has no relation with the summation. You have to take it outside and take it to the RHS. Are you getting 3n, is it, Shashank? And Ketan is getting n and you are getting 3n. How come it is so much of difference? Okay, just check it. Okay, okay. Complete the calculation. Tell me the final answer. Do the final answer. Okay, yes. I don't know. I can't see your calculation, right? Do the final calculation here. Okay, I think this part we can clean. Okay, eraser. This part has to be clean. This can be clean. Okay, yes. So quickly. I hope you can see this. Okay. So what you do is here you can go for further. It is n cube, okay, plus 3n square plus 3n, correct? And then here equal to 3 is outside, summation k square here, and then go for here plus 3n square plus 3n by 2. Take plus n is there. So take everything these things to the RHS. So you will get it as n cube plus 3n square plus 3n here, and then minus 3n square minus 3n by 2 minus n. So go for the further calculation. Okay, fine. After you get the cubic equation, please factorize it. Please factorize that. Okay, and then you will be able to get it. Okay, yes, fine. Will you do that, students? I think it's already 7. So you can just stop it here. Okay, yes, time up. Yes. So please complete this last part. You get a cubic equation, factorize it, and then you will be able to get it. Okay, and don't forget, see, this is equal to here. Don't forget that 1, 2, 3 which is there. This is equal to 3 summation k square. So don't forget this. Then only you will get here 6 as the denominator. Okay, so do that, complete it. You'll be able to get the answer. Okay, yes, Ketan has already sent the answer. What about others? I don't know. Okay, yes. So see that you complete it. Okay, we have actually this many problems to discuss. I don't know. I've taken few different problems from there. Okay, yes. So anyhow, let us do it in the next class. We have lot of questions in the test. You will understand tomorrow. Okay, so do that. Okay, yes. So thank you, students. Please complete it. Your answer should be n into n plus 1 by, sorry, 2n plus 1 by 6. This is your answer. Okay, this is your answer. Please complete it. And this will be another one you can try with the fourth degree. Okay, yes. Okay, yes. So that's it. Thank you. Yeah, you can complete it. Complete it. Okay, complete it at home. I'll not take more time. Okay, thank you, students.